Hey there. Welcome to Datadog's replay of our inaugural serverless event, Bits of Serverless. I hope you'll enjoy the content. Don't skip over too many of the talks, or you might miss out. And don't forget to sign up for a free trial.
It's really exciting to be here today. We've fostered this community of serverless developers and companies using serverless, and we're really excited to share what we've learned and, most importantly, what our customers and our partners have learned in building their businesses on top of serverless today. We get a lot of questions about how do I run my business on top of serverless, or how do I build this new application in a serverless way? And we're in this unique position where we talk to these large companies who are starting to adopt serverless for more and more projects. So maybe it was individual developers who brought it in for smaller security projects and IT projects and cron scripts. And serverless adoption has really expanded so much in these companies. And so, I'm in conversations with, I remember one with a CIO who said, any new project at our company needs a reason not to be serverless. On the other end of the spectrum, we talk to a lot of folks who are literally building their businesses on top of serverless today. So from day one, everything they build is not constrained by infrastructure hosts, by infrastructure that doesn't scale elastically. And so we're really excited to bring together all these folks in this conference today and to have you all here to participate in this live serverless event. This is our first time running this event, and we're really excited to have the folks that we do here and that this is all live so that we can get all of your participation. And I think you should feel special in being the folks who are building on top of serverless and here to engage in the broader serverless community today. So, unlike a live event, we're not hosting happy hours or walking around to talks together, but we have all the same participation tools here today, and all of our presenters are here to answer your questions and to engage. And so we encourage you to meet other people while you're here today and ask all the questions that you have. And we have a number of exciting workshops and talks that will happen over the next couple of days. So with that, I think I'll hand it back to Andrew as we get started with the rest of the day. Thank you.
Great, thanks for those thoughts, Stephen. Before we jump into those pre-recorded talks, I just want to remind everybody, don't forget, especially if you're just joining us, that we're ready to chat with you live via that Zoom Q&A feature at the bottom of the window. We're going to have a live Q&A session at the end of every talk. Also, you can just chat with us if you have feedback on kind of the event or questions. Or I think one of the coolest things at in-person conferences is always seeing somebody and saying like, hey, I didn't know that person is a Datadog user. I didn't know that person is a serverless user. So feel free to have that kind of engagement in the chat channel. We'd love to see you talking all day long. That said, we'll just get right into it here. Our first talk of the day comes from Zain Raza with Frame.io. He's going to be sharing some critical learnings from Frame's need to scale during COVID-19, which I think is a topic that's important to all of us. Don't forget, during the talk, feel free to keep those questions coming via that Zoom Q&A feature. And with that, we're going to go straight to Zain.
Hello, and thanks for joining me at this session. Today, I will be talking about some lessons learned in our serverless distributed video encoding pipeline while experiencing some extreme surges and spikes in usage during COVID-19. I'm Zain Raza, the Director of Video Engineering here at Frame.io, and our team is responsible for running our core media asset ingestion and distribution pipelines. Frame.io is a cloud-based video collaboration platform designed to streamline the video creation process by centralizing all media assets and all feedback in one secure place. Our mission is to power the world's video creation. As with most remote workflows, all of these platforms have seen surges and increases in traffic, and so have we. And due to that, because of the change in the usage patterns, we experienced some spikes. This talk will focus on an incident, and some spikes and surges and how we handle those and lessons learned. The agenda is as follows. First, we'll get into the media pipeline from a high level. We'll jump into the architecture of the pipeline, just why we chose this architecture, what our recent incident exposed, and some key takeaways, and then we'll open it up for Q&A. So getting into the Frame.io's media pipeline. This is oversimplified, but just to give you an idea of what processes follow once a user uploads a video. So at its most basic usage, users come in, they can upload multiple assets. They could be videos, they could be images, and many other formats that we support. Once an asset is uploaded, there are certain steps in the pipeline that trigger. We have an analysis on the pipeline, there's transcoding, we do checksumming, and after which the asset's ready for playback. We also stream the asset using some watermark security, which is done via a Lambda serverless HLS on-the-fly packager. And then just jumping into the high-level architecture of the pipeline. So as mentioned before, once the users come in and they upload an asset, we trigger CloudWatch events. Those events then trigger step functions, which then are using Lambda to orchestrate the transcoding pipeline. We add run tasks to our ECS clusters, which are predominantly running on spot fleets. And once the assets are completed, they're transferred over to another S3 bucket. So why did we choose this architecture? Time to market. Using serverless wherever possible and AWS managed infrastructure gave us the ability to get the infrastructure designed and deployed much sooner than it would have otherwise. It was cost effective. Running on serverless, you were paying only as per usage. Availability is highly available, highly scalable, and secure. So we use like least privileged access in our AIM roles. And each transcode task is run in its own spun up container, so it's kind of sandboxed. So the incident that we're going to get into deals with certain service limits that we started hitting and their cascading effects. So I just wanted to give a little overview of what AWS Lambda throttling is. AWS has a default 1,000 concurrency per region in Lambda invocations. We've had that increase to 6,000 via AWS support. Whenever the concurrent number of Lambda function invocation exceeds this limit, AWS starts to impose throttling. And as a result, the request get rejected. And this could be triggered by various event sources like SNS or API gateway, amongst others. And by default, this limit is applied to all Lambda function invocations. So it's not like it's per function, it's all your functions that are running. And if they exceed this limit, throttling gets applied. There are also other services that have throttling and limits. Lambda we just spoke about, ECS run tasks, step functions, CloudWatch put metrics, and parameter store are some that we use that also have limits. So we should keep these in mind. So jumping into the incident. So October 29th, around 4:30, we started seeing general slowness in our transcode jobs. Our uploads were working as expected, but their transcoded assets were either failing or taking a really long time. How did we detect this? So 10 minutes into the incident, we got a Datadog alert. We are Ops Genie, notifying us that the Lambda function invocations are being throttled, as you can see in this graph. We have another graph that started showing us Lambda invocation error rates were rising. And actually clicking into this real-time graph, which is the screenshot that I took previously, we can see if we go hover over the section that was happening, you can actually see the invocations that were being triggered and their names and which ones were there. So this actually helped us hone in on the issue. And I just wanted to show you guys an overview Datadog dashboard that we have, which is very useful to correlate events. So this is a dashboard we use, which has all our dashboards thrown in, so it's like a master dashboard. Over here, you can see ECS run task rate limits are being hit around 630, 626. Another interesting stat over here is that our CPU usage actually started to drop. So generally that's a good thing, but over here, it was because no jobs were being processed as far as the transcode jobs. So that was interesting to see that. And then going down, you can see at the same time, Lambda step function execution error rates are rising, and all the rest of the correlated dashboard. So this actually helped us figure out which area to hone in on. So root cause, I mean, we have upload spikes all the time. Why was this worse than usual? We saw an extremely large surge of small size but high resolution image uploads. And generally that's okay, but in this specific case, the quantity was way too much. It all happened at the same time. And with bigger assets like video, that spike that happens is spread out over time. So the invocations that we do with Lambdas and the rest of the services do get spread out. In this case, everything happened at the same time. And the spike caused several cyclical rate limits. And these rate limit errors resulted in a gridlock in the pipeline, which got exacerbated by new and retry logic that we had. So then some other related Datadog dashboards. This is the Datadog conference. I thought I would add some other insights that we have. So in this dashboard, we can see everything kind of spiking at the same time. Over here, we're seeing the state machine executions rise. At the second graph, we're seeing Lambda invocations are rising, surging. We're seeing some no resourcing cluster errors from our ECS cluster. And then the last graph shows Lambda throttles that are starting to happen. Some immediate actions that we took. We stopped all new uploads from hitting our transcoding pipeline. So users could still upload content. It was just not being transcoded. And this was done just to be able to allow the existing load to drain out and achieve stability. Once that was happened, we have certain backfill jobs that we can go back and run with metrics that we collect on all the uploads that just get reprocessed. So some short-term actions that were taken. Because we're using CloudWatch logs to sync to Datadog, the sync for us takes about 10-15 minutes. As a result, we created a Lambda function that creates a custom metric in Datadog, giving us immediate notification of such an event. This was a quick fix, but now we're looking to adopt Datadog's Lambda enhanced metrics, which will give you real-time alerts that we could have used in this case. We're optimizing our retry backoffs to prevent waves of throttling. Within our code, not within the AWS's SNS sections, but in the code itself, we were retrying tasks too aggressively. So now we've optimized a retry backoff rate to slow that down a little bit. And finally, we handled non-critical CloudWatch metrics appropriately. Trivial metrics were blocking our critical paths, so they're not doing that anymore. And also we plan on requesting another increase to our account limits. Mid and long-term actions taken. So instead of relying completely on, when going with the distributed serverless architecture, on a managed infrastructure, which has a lot of benefits, but it does make us think of adding some level of control. Queuing is a very common practice for controlling the bursty nature of web service and API requests, which also occur in the media pipeline. And this is something now that we're looking at introducing. One way to do that is using AWS's SQS long polling. So instead of triggering SNS notifications to fire off an event and trigger the next action, a message can be queued and consumed in a more deliberate fashion, thereby reducing pipeline bursting. And then, we want to be able to handle dead letter queues in this case as well. Also, queuing, when using queuing, prioritization is important, so we can prioritize the jobs by job type or by customer. So, enterprise customers maybe get a higher priority. And so there are various ways you can optimize the system by using the queues. So where would we add SQS into our existing pipeline? So previously we saw the diagram for our pipeline. And in this one, we've introduced SQS, as you can see, between the CloudWatch events and the step functions, and also using Lambda's dead letter queue SQS and handle that from another Lambda that we can retry at our own pace instead of bursting ECS stats like it was before. Key takeaways. So it's really hard to completely eliminate throttling limits. You can ask for increases, and that really does help, but I feel like designing the system with those limits in mind is prudent. And here are some of the following steps that could reduce the likelihood of running into these issues. Request an increase from the default 1,000 limit by opening up an AWS support ticket. You'll most likely get it. Ours is up to 6,000 today, and we do plan on requesting another increase. Consider reserved concurrency per Lambda function. So you can split up your concurrency reservations per function. Think about using maybe more reservations for critical functions or burst functions that are bursty in nature. These are just some basic examples to consider. Use a queuing method, which we spoke about, SQS dead letter queues, for sure. Those will help a lot in retries. Look at your retry logic. If it's too aggressive, put some exponential backoffs there. And then, in general, just improved alerting. So we touched upon this earlier on. Datadog's enhanced Lambda metrics provide real-time alarms for such use cases. So thank you for joining this session. I hope the key takeaways prove useful. This was a real-life incident that happened, and it happened because of a certain change in usage patterns that previously didn't exist prior to COVID. So remote workflows have really increased, and specifically Frame.io's tool, which is a remote collaboration tool, saw these surges, is experiencing a lot of traffic, which is great. And we are adjusting and optimizing to these various changes in usage, with spikes and surges, not just a steady increase in traffic, but just the load changes as well. And at this point, I think we're going to switch to Q&A. So thank you again, and enjoy the rest of the conference.
All right, thanks so much, Zain, for that great insight there into how Frame.io leverages serverless. We didn't have any questions come in via the Q&A panel, so I'm hoping that you found that Q&A panel. If somebody wants to just go there right now in Zoom and ask a question, any question, it could be even expressing your preference as to whether you like to use a conferencing puck or you like to use large headphones like this on a conference call. I just want to know that that Q&A feature is working well in the Zoom webinar throughout the day. A couple of folks gave us a heads up that we're experiencing some blurring on the stream. We're going to do our best to try and deal with that, but in the spirit of keeping on time here, since there's no questions, I think that we'll move right on along to the Vercel talk. It's my pleasure to introduce Guillermo Rauch, the CEO of Vercel. He's going to be sharing some learnings from the front end of serverless, which for me, I think is, as a former back-end engineer, the front end is one of the most challenging pieces to really instrument, monitor. Oh, we did have a question come in on the frame.io talk, and we're going to make sure to get that to Zain, and we're going to get it answered. But right now, we're going to move on to the front end of serverless with Vercel.
Hello, everyone. Today I'm here to talk about serverless frontend, which is a topic that I've been really passionate about for the past 4 years when we first launched Next.js. As our platform Vercel grew, we realized there was a unique opportunity to merge the concept of a framework that is tailored to front-end developers with infrastructure that is tailored for the modern serverless world. And with that, we could get tremendous scale and performance benefits as a result, while minimizing the amount of work that developers need to do to push and get their stuff out there, to preview their changes, to collaborate with their peers, and to ensure that performance is attained as their front end evolves. And specifically, I'm talking about serverless front end and not back end. So I think that the opportunity for serverless is most interesting to front end developers, and that's something that my talk is going to go into. So I'm going to get right into my presentation. One of the key things about this architecture is that there's three main goals that we had in mind. One was to maximize developer experience and eliminate toil. The next one was to maximize collaboration between developers and the rest of the team. And finally, that performance had to be great for end users. So there's no point having serverless whatever if users are not happy and they don't have great perf. On the subject of developer experience, a lot of you that have met the modern front-end world, you know that it's just not trivial to get started at all, whether it's tons of Webpack config, Babel config, making sure the SSR actually works at all, and then someone else comes and says we have to have AMP support, and you need a router, and at the end of the day, you end up with like homegrown conventions for just you, your team, or your company, and then no one understands how your DIY front-end framework works. And then as it relates to infrastructure, there's even more config and more things to worry about. Configuring the CI/CD pipeline, configuring all that YAML code that makes the front end actually even work or deployable, that makes it scale, that makes it deploy without downtime, so that, whatever, like containers get replaced and things. And at the end of the day, you don't want your users to drop requests. So Next.js is our solution for this idea of having a universal convention and great developer experience for the front-end developer. Starts with the file system, and that's a very interesting benefit. So you just create my app folder, put a pages folder inside, and then any file that's in there becomes a URL that is accessible by the end user. And it's basically at its heart just React. So you just export a React component in that file, and you're off to the races. Later on, you realize that, oh, I want to have some data associated with that component. And the answer here up until Next.js had been, well, use a single page application, do all your work on the client side, which is really not good for SEO. It's really not good for the first paint, the first boot up of having great performance when you first load a page. No one likes spinners on the client side. No one likes huge JS bundles and so on. So Next.js introduced this concept of built-in static site generation, or you could call it JAMStack support, where we give you methods like getAsstaticPaths. In this case, slug, which is a special type of file, can desugar once it's built to lots of posts. And then getAsstaticProps, the second function you see there, to actually get the data. So instead of a single page application, now you have HTML that actually contains the data that your users were interested in, which again improves SEO, improves performance. It makes sure at build time that your backend works correctly. It has tons and tons of benefits. But that's not the only way to use Next.js. So Next.js is what we call a hybrid framework. So I can go ahead and define a store that instead of just statically fetching data, it can fetch data for every request. So this is the age-old server-side rendering. So unlike single-page application frameworks or Create React App or Gatsby, Next.js also gives you the ability to fetch data just for that user. And this has given Next.js a huge advantage in fields like e-commerce, where increasingly conversion is not just about performance, but also the ability to personalize content and recommend to me, who I'm in San Francisco right now, that I get a light jacket as opposed to a snow jacket, which is maybe something you would want to sell to someone in Canada or New York in the same season. And finally, another capability that also is just a file system primitive is you can define an API folder and you can create what we call an API route. And here you can talk to any backend. You can return JSON, XML, plain text, whatever. Notice the async keyword is missing there, but this is any async and await workload that you want. And this gives the front-end developer the ability to go a little further into the backend, which is really cool. So the X is great. There was no config, no webpack. It was just literally just a file system, great conventions. But we also promised to reduce toil. I love this word. As a non-native speaker, I didn't know what it was, but when I was reading the Google SRE book, which had a profound impact on me, they said that one of the main goals of an SRE team is to minimize toil. The kind of work that is tied to running a production service, but it's manual, repetitive, just like gross. You don't want to do it. So you can think of Next.js as enabler of a non-toil operation of your front end. And that's because of its design as a serverless friendly framework. And what do I mean by this? So you've probably heard about infrastructure as code. I called Next.js serverless infrastructure as app. Why? Because the infrastructure is completely invisible, it's serverless, and the app defines the actual infrastructure. There's no, you're not referring to infrastructure, it's just happening as a result of it. So think of it as like when you run the build command for Next.js, next build, we terraform the most optimal cloud configuration for those pages and that source code and that application that you define. So index.js, it was completely static, right? It had no data hook. It was just hello world. So let's build it as HTML and push it to the edge. The blog, it was statically generated because we had to get static props and get static paths. Okay, build a bunch of HTMLs at build time, push them to the edge. Store was SSR. Okay, let's create a Lambda function that also, by the way, is tied into the global edge network so that it can cache if it returns cache control and deploy it automatically. Same with Track.js. And this relates to a concept, this optimization, right? Because we're not just we're not creating a container here. We're outputting static files and functions, and we're doing all automatically on behalf of the developer. I wrote a blog post called Static Hoisting because a lot of people misunderstood this new wave of serverless front end as saying, well, isn't that just a static hosting? Well, no, because you also have functions, right? So this combination of hoist what's static and push it to the edge preemptively, and then you can also do dynamic code execution, so it makes this architecture quite special. And as a super simple example, even though we have customers that are leveraging this infrastructure for very, very big things like TripAdvisor.com and many others that are hosting their front ends on Vercel, I like to use this example of Patrick, the CEO of Stripe, obviously very busy man. He runs a very simple site that if you and I looked at it, we both say, well, obviously it's static, but it wasn't entirely, because it was before Vercel, it was a server. He used Express.js, he used a static middleware. He had a donation endpoint that used Stripe. So I'm assuming that just like most CEOs out there, they like dog food in their products. He was trying to like dog food Stripe. So he said, okay, I'm going to turn my blog into a server. Pretty reasonable thing to think. But here's the deal, right? Like if you have a server like that, even for something simple, what happens when traffic spikes? Well, you forgot to configure server autoscaling. Oh, what happened when US East 1 goes down? Oh, yeah, I don't know. Like it just will come back later. Oh, and what about performance? Oh, yeah, I forgot to configure my CDN and cache and purge and so on. So you see where that story goes. Once he moved his personal website to Vercel, we just simply take all the static parts, hoist them, and push them to the edge. All CDN caching and invalidation is completely automated. And then the one function that he had that had to talk to Stripe works like CGI bin. So you can imagine API/donate is all he needed to do to define his dynamic endpoint. And the infrastructure of all this is completely invisible to him. In fact, he deleted all the Express.js code. So by deleting all that, he just went from Express.js to just his content. No need to configure cache control and purging and CI/CD scripts. He imported his repo to Vercel and he git pushes. The main branch becomes the .com, and every PR gets a deploy preview. So when you think about this idea of a static and static generation, static generators, and so on, the JAMStack sort of universe has taken some space of, okay, what is JAMStack and why do I need it? And the way that I explained it in terms of infrastructure is JAMStack is just this idea that if something was a static, you should push it to the edge and it should be static. It shouldn't be confined to inside a server, for example. I look at it as a mechanism for maximizing cache hits and not having to boot up a server to just to boot up a static middleware to look at the file system to render that, and then having to configure cache control to make sure it's a CDN and whatnot. But the interesting thing is we took it a step further and we said, okay, so there's a lot of workloads that are obviously static, right? So the homepage of your company, company.com, or your documentation website, those are seemingly good fits for JAMStack, and yet JAMStack had a lot of pitfalls, right? So for example, if you want to change one page of documentation, you have to rebuild the entire site. If you want to preview some content, you have to build the entire site. Adding a page or changing the content of one page requires the entire static site to be rebuilt. So Next.js gives you also not just SSR and static, but an in-between between the two technologies that we called incremental static generation and regeneration. So broadly speaking, the workflow starts with you have a preview support. So you're always going to have some sort of CMS or data layer that is backing your static pages. So imagine being able to customize the CMS content. And then when you want to actually preview it, and this would be an example of something that would happen inside your CMS backend, you can now say, okay, I'm going to synchronously render the entire site, rendering the content that's coming from my backend data source. So for this simple example, which you can check out yourself, called next-preview.vercel.app, we're using S3 to store these changes, but it could really be any data source that you want to power that statically generated page. So Next.js and our serverless infrastructure behind the scenes, which uses a combination of functions to render just in time or static files to power the cache, we can have this best of both worlds experience where like a non-technical team can preview the entire site coherently, where all the data is in synchrony with the draft or with a preview version of their database. And then later on, the actual result is always a static at the edge. So when I exit preview mode, this entire experience is super optimized. So you're going to see that once I analyze the headers here, I'm going to see that it's always a hit. And it's always really fast to fetch. However, when I'm in SSR mode, I'm directly going against my database. I'm using functions. I'm rendering just in time. I'm bypassing all the caches. So this is a really cool property because for those of you that are familiar with WordPress, you know that this was something that was built in. You could, of course, read your writes and see the data that you're updating in the backend in real time. But once we went JAMStack, that kind of became more difficult. And the same goes for adding new static pages, right? So we have this cool demo here. It's called a static tweet, where again, everything is static. Even the embedding of the tweet, it doesn't use an iframe. It was immortalized there with 242 likes when the page was built at build time. But as you could imagine, there's infinite tweets, practically speaking, right? So we added this random generator that gets like fresh tweets. And if I open one, it happened too fast for us to notice there, but what happened was it was a skeleton, and that was the fallback skeleton, kind of like a single page app. Then we fetched the tweet just in time, and then we generated, and then we pushed it to the global file store and edge cache as if it was a static page that was generated at build time. So this is another way that serverless infrastructure allows you to go beyond the confinements of JAMStack and static sites. And you can try it for yourself. Copy and paste here. So the very first time, I guess I had the same one there. The very first time it's fetched, we're going to, I guess I picked the same one again. There, finally. Okay, so very simple. You use get static props in combination with get static paths in combination with a fallback function that we call. In a similar manner, incremental static regeneration works, where this page again is a static. It fetches a bunch of data from GitHub, but if I go and modify the data source, so I'm gonna add a new reaction there to 271. Notice that the first refresh, I press Command R, said 270. Why? Because from the perspective of the user, it's always a static and at the edge. Then in the background, it regenerated, it built a new page, and it pushed it, and now it has the new value that I wanted. So that's another way that, again, service infrastructure is allowing us to, in this case, a background function is computing the new page, and then sort of adding it to this global cache such that we can get all those extra CDN caching benefits. But doesn't mean that incrementally static, even though it does get you more than pure JAMStack, doesn't mean that you're going to throw away SSR. We enable serverless site rendering. So the example of the store where I'm fetching products that are just for that user, we can still compute the data in the cloud and not have to resort to client-side JS to do it. The second point of the architecture was to maximize collaboration and experimentation. And one of the things that has emerged here is that because we piggyback on serverless infrastructure, every push that you make becomes a cheap new URL that we can provision in our network. And every time you push, we give you a brand new URL where you can test your front end. And when I mean you, I don't mean just you, I also mean integration. So for example, you issue a deploy preview, we can issue automated end-to-end testing against it using headless web browsers via integrations like Checkly. We can issue performance tests, and I'll get into this a little bit later in terms of performance. You can run assurances against whether you validate that you have a certain SEO conformance, like having Twitter cards and SEO descriptions and so on. But then when it comes down to your team, you can collaborate better with QA teams and product management and designers and accessibility teams, communications, and even your CEO. And notice here, I'm still saying that it's front-end that enables better collaboration. And the reason here is the front-end developer is now uniquely positioned to leverage the existing APIs from their team or new off-the-shelf ones. So think of it as like the backend tables that we used to have to create in the past, right? So instead of creating a user table for our backend, now we use Auth0 and Magic Link. Or we used to have all this machinery for invoice and subscription, and we use Stripe. Post categories, and we use headless CMS. This is where it gets really interesting because we can use all these incredible ways of enhancing the ability for the rest of your team, those of you that are not front-end developers, to contribute to the front end. Because now the content gets pushed into a content API like Sanity, or you can even use the WordPress API. And the same is happening with e-commerce sort of in parallel, where like products and orders can be get from Sailor or Swell or BigCommerce or Shopify. And this enables everybody else to not have to become a GitHub expert, a front-end expert to make a change to the front end. So the front developer almost acts as a means of disintermediation, right? Like you work to set up the Next.js infrastructure, to hook it up to all these centers of collaboration that provide data to your front end, and then you enable other people to contribute. A great example that I like is we put out Next.js Commerce, of course, because Next.js is just a front end layer. We use BigCommerce as a way of getting all the commercial transaction APIs in place and all the data for your e-commerce. So you can check it out at next.js.org/commerce. But one thing we realized is that e-commerce is not just about items and products, but it's also about content. So we have a fork that uses Lexus CMS. So Next.js, again, allows you to pick from many of these off-the-shelf APIs. So we combined it with Lexus CMS and BigCommerce. And now with Lexus, if you look at the sidebar on the right, you can now start targeting content. And again, without having to code at all, your non-technical team can say, okay, for this audience, I'm going to experiment with pushing a certain type of product, a certain type of promotion, and then I'm going to measure the results. And then with Next.js preview mode, they can experience what that scheduled content promotion is going to look like in real time, which is pretty incredible. And I like to mention that headless is an enabler, not just of collaboration, but it's also something that makes sense in today's day and age when you think about developing an application and not having to do all the work yourself. So something I've heard a lot over the years is like, where is it Ruby on Rails for the modern React world and modern front-end world? And my answer has always been, it's here, it just doesn't look like Ruby on Rails, because Ruby on Rails is all about you write your entire content backend. Even their first screencast that launched them into popularity was about creating a blog backend. So I captured this screenshot where like there's a database inspector in the back and there's the editing posts in the front. And nowadays it's something that we can get off the shelf, and we can get experiences like Lexus CMS and Sanity and Strappy, and we can combine it with other ones that are more specialized for certain types of objects for e-commerce. So in short, headless decoupling is not just about, oh, I feel better that I have a better architecture, or I'm leveraging microservices now because my front end is talking to my content microservice, but it's actually enabling greater collaboration experimentation, because these UIs are UIs that don't require coding. They don't require becoming an expert in React, and yet they are enabled by the people that are working on that React front end. And that goes into the last and most important thing to me, which is serverless, headless, React, JAMStack, incremental generation, SSR. These are not useful unless they're allowing us to deliver great end user performance and great UX. So I have to be honest here, serverless, when it comes down to performance, is still a minor contributor. So the CDN part, yes, that's awesome and it will help a lot, but we have to be aware that front-end performance has been misunderstood a lot. So I like to liken it to an iceberg. And the traditional interpretation of the front-end performance mental model has been overly simplistic, which is, okay, I use Next.js static generation, I hooked it up with incremental, I have my caches all set, then it's just, I use JS responsively on the front end, right? On the client side. That's going to get me great performance, right? Actually, it's very different, because the CDN giving you the HTML, JS, and CSS really fast is very important. But then you get into like all kinds of bottlenecks in the front-end rendering pipeline outside of where you hand it off. So a great example here I like to give is box shadow. When the very Facebook team rebuilt Facebook.com, they didn't use box shadow, they used background image instead of box shadow, because they found, and they shared later on Twitter, they had to use an image because the box shadow CSS property, what was quote unquote correct, was killing performance in browsers. And it's something that was even hard to detect because they had to like stress test with browsing back and forth. This is where I imagine, the deploy preview infrastructure being so useful to teams like this, because they can issue a preview of the new navigation, and then someone can be like, oh, I'm scrolling and it feels slow. And then the front engineer goes, you're right, product manager, we should replace this box shadow with a background image. And it's not even just about that. It's so many things that can go wrong, like web fonts and poorly schedule GDPR pop-ups and all kinds of scripts. Where Next.js is starting to help with some of these, like images, for example. The new Next.js image component gives, in combination with the Vercel image optimization serverless infrastructure, will give each frontend the right sized image for the device that is accessing your site. And images are a huge part of this iceberg. And some of these, like a lot of these scripts, could be pushed to server rendering, for example. So if you find that you're doing a lot of rendering on the client, you can also send it back to serverless, right? So it helps there as well. But what truly helps is to actually have a mindset of continuous performance assurance, because otherwise it's just going to be too many traps, like that box shadow trap, and you're going to feel disappointed that, oh, this incredible modern serverless front infrastructure was not that helpful. That said, there's two things that we're giving you to put you into that journey on continuous performance assurance. So one of them is deploy previews, as I mentioned, are great candidates to have highly parallelized Lighthouse CI done against them, because that deploy preview is using the same high performance front-end infrastructure we're using for production. And the other one is our built-in real user monitoring, where Next.js, for example, will automatically start reporting, obviously if you enable it, to your dashboard the Lighthouse score, but computed from the perspective of your real end user. So this is really cool, because the 90 that is reported from your users is way more valuable than the 90 that is reported from a synthetic test. And you can combine both of this to get the best possible workflow to ensure that performance stays great. And then you get a dashboard that understands deeply into the front-end framework. So it's not that we just understand the front-end framework deeply to like do static hoisting and create functions, but then create static files and that. But understanding the front-end framework deeply allows us to also tell you, we think that page/blog/slug is the thing that you have to fix because it has a bad what we call real experience score, which is this idea of a Lighthouse score computed from your actual traffic. And this is not just limited to Next.js, but any project that you import into Vercel, if it's a modern front-end framework, we're likely to have or develop a analytics integration as well, so that you can get all these benefits. Even if you port front-end solutions that you've already built, you can hook into the Vercel primitives, not just for serverless, but also for performance monitoring and a lot more. Which is to say, you can modernize your front end incrementally. You don't have to just, tomorrow rewrite in Next.js. So to recap, three main goals that we've achieved. One is maximizing the X, reducing all the SRE work, enabling non-technical folks to contribute, but also greater experimentation through deploy previews and headless data architectures. And ultimately, this is to serve a user, a visitor. And that user and visitor deserves a great performance and great user experience. And the best way that we can do this is by a combination of great infrastructure, great CDN, great caching, but most importantly, constantly challenging our intuitions of performance and ensuring that our front end lives up to the expectations. If you want to learn about modern front end development, go to nextjs.org/learn. We'll teach you how to build from one static page to lots of fully dynamic pages. You'll learn about all the data hooks that we talked about. And to start deploying this modern front end infrastructure, go to vercel.com, import your Git repository. We'll give you deploy previews for every push. We'll deploy to our global edge network, and you'll start taking advantages of features like analytics to ensure that your performance is great all throughout. It was very fun to give this talk because it talks a lot about why Next.js was created, why we designed it the way we did, and how it was perfectly timed in this sort of serverless wave, and the Vercel platform was able to leverage a lot of these new architectural primitives to not just give you a great DX, but also a great end user result, and give you that ability to scale from whether it's your personal blog to some of the largest websites on the internet that today are powered by our infrastructure. I hope you enjoyed, and thank you for tuning in.
So I know that we have Guillermo and Zain here, so feel free to decloak, guys. You can turn on your video and join a live Q&A here. So apologies in advance. We were running a hair ahead of schedule today. We continue to run ahead of schedule today. So we're going to likely figure out a way to put in a little break here, which wasn't previously scheduled. But for now, we can take some questions. We can take questions from the audience on Zain's talk or Guillermo's talk as soon as Guillermo is available here on the stream. We had several good questions come in for Zain during the course of the session here. So can you hear me, Zain?
Yep. Can you guys hear me?
Yep, we can in fact hear you.
Cool. Happy to answer them here as well, if you want.
Yeah, thanks for that. So I think your business is super interesting because video is one of those things that lends itself really, really well to serverless workflows. So one of the questions that we had come in advance is what framework does Frame.io use for deploying their serverless code?
Right. So it's a combination of code pipeline and Circle CI.
Okay, but do you make use of, like, are you just throwing those in CloudFormation or Terraform, or are you making use of something like serverless.com or AWS's SAM?
So we have Terraform templates mostly for our Kubernetes deployments. And code pipeline, I believe, uses some CloudFormation templates as well.
Very cool. I think we're going to continue to see that space kind of evolve,
Right.
but I'm skipping ahead to the panel topics now. So here's another great question. How many accounts are you running? If that's something that you can share, feel free to just say a little, a lot. And how are you managing the service limits for each of those environments?
Yeah, so we're running about, I would say, 5 accounts: production, development, security, and sandbox. So actually 4. And we haven't had issues requesting service limit increases for specific accounts, but there has been some pushbacks for getting an increase in all the accounts at the same time. So it's individually calibrated.
And what will you say, like, some of the kind of common pain points are when you're onboarding a brand new account, like for the business? Is there like a specific service limit that you would say you run into more often than not?
Yeah, so for us, when we are opening a new account, using our existing architecture, we usually run into run task rate limits a lot. So those we've actually calibrated using reserved concurrency and increased those. Generally, we do request a general increase of 6,000 at this point is what we're asking. In fact, after the recent incident, we're probably going to go request some more. But yeah, we do look at different functions, some of bursty nature, some more critical, and we do try and calibrate the reserved concurrency on those.
All right. Making any use of anything besides reserved concurrency, any of those other features like provisions or other types of concurrency, or is it just reserved?
At this point, I think it's just reserved. I might have to get back to you on that with more details, but I do know it's reserved. Yep.
Right. Well, keep those questions coming, folks in the audience. Let us know if you have any questions either for Zain or for Guillermo as we roll on here. We're running quite a bit ahead of schedule here, so we want to make sure that we answer your questions through this. Feel free to ask literally anything, even up to and including how's the weather where you're at. We want to take advantage of the fact that this is a live Q&A, so keep those questions coming in the Zoom Q&A. Guillermo, thanks for joining the stream here so soon. I know we're a little ahead of schedule, so thanks for the flexibility.
No worries. Thank you for having me.
Super great talk. I mean, there's no questions that have come in here, but I suspect that you spend an awful lot of time thinking about browser performance.
Yeah. Yeah.
Based on that, is there any tips and tricks that you can share kind of from the front end with regard to like just how you sort of manage this world that we live in where we have these different browser engines? I mean, some of them are consolidating to Chromium. But I thought your CSS shadow box example was super, super great because based on the engine that's behind the browser, there's so
Right.
many behaviors, right? And so many pitfalls. So can you just talk a little bit about that?
Yeah, for sure. So one of the most interesting things that have happened, I think, this year, as we wrap it up, is that Google advanced this standard of Web Vitals, which are basically the most important metrics about web performance. And a subset of them, the core Web Vitals, are the ones that starting March next year, Google is going to start using to rank websites. So I like to call it, the biggest advancement in site ranking since PageRank, basically, because it's not just about matching the right content. It's about giving you content that's delightful, that opens quickly, especially in mobile phones, especially with our ever decreasing, attention spans. So I would say when you think about the work that Zain is doing, for example, on backend serverless, you look at things like the monitoring dashboard of throughput, latency, provisioning amount, like throttling per second. You have all these metrics to understand how well, your data is flowing through the backend, how fast it's being processed, and so on. But on the front end side, we never had something like that. In fact, if you only looked at, time to render or something like that, you'd be looking at that only top portion of the iceberg, and you'd be looking at a very little amount of information, really, because then the rendering pipeline begins and it's really hard to understand if you're being fast or slow. So I think with Google creating this Web Vitals, we can finally get some heuristics, at least, that relate to the actual experience. And with your question with relating to different browsers, they're all starting to adopt this as a reporting mechanism. So right now, Next.js Analytics will grab that data from Google Chrome primarily, but then other browsers will start reporting things like largest contentful paint and so on. And even that's still not enough, right? Because the example of Box Shadow relied on somebody just scrolling really fast and complaining that performance wasn't great. And I think that'll continue to happen a lot, right? But having Web Vitals and having a workflow around them, both in the CI/CD side and also understanding how your actual front is performing in the real world, I think it's going to move the needle a lot. And it's going to simplify this world that is really, really complicated.
Yeah, this is my first kind of time hearing about Web Vitals, so major learning for me. I just remember lots of days when I was boots on the ground, like doing engineering, looking at AppDex scores, and I know that anything that you can kind of do to distill that down into one metric for the business is always really, really helpful. Just speaking a common language. What's the deployment story like at Vercel, like as far as your own infrastructure? Can you share anything?
Yeah, for sure. So the primary point is we have to be global. We have to be a highly available, reliable, really fast distributed system. That's the value we give to our customers, because the ones that are removing that front end pod from their cluster and are pushing their front end to the edge, they're getting this massive availability benefit. So right now it's we're in every single AWS region. We basically terraform our ingress layer on top of existing cloud providers. We think of the edge as a tiered system. So when you think about going to website.com, our priority is to terminate TLS as close as possible to the user. So that might not be where your actual code is running if you're using server rendering, for example, if you're using functions. But Vercel will accept users' connections all over the globe. So we terraform basically every cloud provider. We set up our ingress layer there. And then that starts acting as both the scheduler of code execution for the incoming requests, so in terms of scheduling Lambda functions, or it's where we do our caching. So a lot of the features that I talked about, like incremental static generation, these are all features that allow us to give you the page that you wanted right there at the edge without doing any further computation and reusing those caches as much as we can. So we use a combination of S3 for content object storage, obviously lots of layers of caching. One of the concepts that I talked about in the talk is the idea of static hoisting, right? So if I build your front end, I know what pieces of data are static. And Vercel's goal is to push that as close as possible to the end user and even minimizing origin hits in the process. So then we have a core API. We use a database by Microsoft called Cosmos DB to power it. One of the cool benefits of this API is that it's similar to Dynamo global tables, but it gives us a lot of fine-grained control over global replication. And so for the metadata of your deployments and so on, global replication, global availability, no single point of failure. So you've probably seen scenarios where Cloudflare's brain goes down, and if the brain goes down, then a lot of the network starts malfunctioning. So we like to think of ourselves as not having any point of failure, not just on the edge where we serve traffic, but also on the API itself. So it's powered by Cosmos DB, Kubernetes, and Lambda. And we're still in the process of moving more of the workloads that are traditionally in containers to functions, but that's an ongoing process.
Yeah, there's so many themes there. And I'm stealing a little bit from the panel that's upcoming, which I'm super excited about, by the way, which is the predictions for the future of serverless, right? Which is that for you and also for Zain, to some degree, this kind of move out to the edge is really something that's interesting. And for the folks that are joining us today who are new to serverless computing, when we talk about moving something to the edge, we're talking about moving that into AWS data centers that are teeny tiny, like almost a micro region where we're homing content so that it can be geographically close to you, or at least close from a bandwidth cost perspective, which is important for performance. It's important for providers. It's important for point of presence type stuff. And we actually had a really good question that came in here that I want to actually pose to both of you. And I'd love to hear each of your answers on this, which is that with regard to your observability, how do you instrument all of your code? And the question said front-end code, but I think that this applies to both use cases, back-end and front-end code. How do you get that comprehensive view through your stack, especially when you're putting stuff out to the edge? And I think we'll start with Zain here.
Right. So most of our observability is using APMs integrated within our various functions as well as our containers. That's where we get our instrumentation for machine performance, function performance, and design. And yeah, and we're not running too much stuff at the edge today. Those conversations have begun. So I can't answer for that edge case, but hopefully the APM answer gives you what you're looking for.
Yeah,
sure. I just know that this gets more challenging. Like the more pieces that we involve, right? Like when we think of even like a video encoding job, we've got that back end job that's taking the bits, it's crunching them down, it's pushing them out to blob store like S3, and then it's going to all these different CDNs. So we think about things like a customer complaint or a series of customer complaints, and being able to kind of put some science behind those as to why someone might be experiencing poor performance. And so I think about those cases anytime I think about a large distributed system that involves the edge. Like, how do you tell a story around what happened to a specific customer? Is it a front end story? Is it a back end story? Does it involve things like real-time user monitoring?
It's mostly a backend story today, although we do have RAM that our front-end team uses. But all our metrics are segmented by accounts, users. So we definitely can drill down into areas where why did a specific user in the APAC region experience degraded quality, for example.
All right. Guillermo, any thoughts on that?
Yeah.
That observability story.
Yeah, this is particularly timely because it's an issue that we're looking into quite intensively right now. So Next.js is very interesting in that it goes beyond cloud computing, call it everywhere computing, because people choose Next.js, or when it came out 4 years ago, because it could do server rendering. Most React frameworks were focused on SPAs at the time, but no one wants to use React just on the server. They like React because they can add hooks to execute logic also on the client. So now you have, for example, when you think about exceptions and exception reporting, you have the client-side code execution, and you have the server-side per request code execution when you're doing server rendering, right? So there's two areas now to worry about. For example, something like catching exceptions or reporting traces and other telemetry. But increasingly became more complicated because with the rise of JAMStack type patterns, we also gave you the ability to run the pre-rendering logic at build time. And that might use the resources of the build container to generate pages and then later on push them to the edge. And then we have this other hook, which is your site might be static, but you can render it in preview mode such that you can render also just in time to see what the eventual content would look like. So there's basically all these places where logic runs, and that's an opportunity for all the problems that pertain to observability, like exception reporting, slowdowns, and metrics that have to be drilled down into to understand why something is slow. So what we're looking to do now is have really great first-class support for integrations like Datadog, Sentry, and so on, support for open telemetry right into the framework, and make this kind of integration that gives you all the surface of code execution, exposes that to the observability provider. And that's something that today is quite hard. We look at a lot of customer setups and they've done all this gluing themselves, and we notice that they're missing a lot of data. So exceptions go unreported, or they forgot this extra hook of annotating the serverless function. Additionally, something we see there as well is that reporting exceptions and things like that today are going into the lifetime of the function. So they might delay the response, or they might make the code execution longer than it should be. So we're looking into what solving that problem would look like. And now we're also looking to add a hook for that micro region you talked about, that micro region that terminates TLS and speaks directly to the customer as the first point of contact, that could also execute code. So we're looking into adding another code execution hook there. So this is why we're investing so much into getting this sort of all these slots for observability providers to hook into automatically and get a detailed picture of the entire flow of the request well into the client side. And hopefully, the dashboards that people can consume thereafter contemplate that entire user journey as you described. I think right now a lot of these dashboards have been overly optimized for the backend world. And for example, the X-ray of the requests kind of ends where that response, that server response finishes, and it doesn't encapsulate the entire front end journey. So it's definitely something that's not solved, but we're looking into working with partners to solve it.
Yeah, great answer with regard to just observability through the entire stack, right? Because it continues to be a challenge. I think that you hit the nail on the head when you said that this is a hard problem. It's an even harder problem when we bring multiple clouds into this. And that's where we really need open standards and we need common patterns. So I think one of the success stories that we really saw for this with regard to like front end code kind of reporting stuff back was in content security policies, right? At the browser level. They started kind of like phoning back for CSP violations very early on. And that's a pattern that a lot of folks have followed for other types of performance and like standards tracking. I don't know how much CSP or security headers like that play into the performance conversation, but I would imagine that they do somewhere.
Yeah, HSTS, for example, will speed up the TLS connection. Like it won't try to go to HTTP if you're in the preload list for STS. So there's definitely benefits that come from letting the user agent to know in advance that you favor SSL and things like that. Using the more modern GTLDs like .dev or .app, those are establishing HTTPS connections immediately, avoiding the sort of HTTP hop. It's a small improvement, but we're all going towards this world of like SSL first, and that helps a lot, right? Like the entire premise of HTTP 3 is what kind of improvements can we make, assuming that the entire world will be encrypted, assuming that there's always going to be a TLS connection there. What does it look like for, establishing, quote unquote, the TCP connection together with the zero RTT TLS resumption? So the more modern the protocol and the more up to date you are with the security standards, the faster you're going to be. This is another benefit of our platform today, is that we'll roll things like HTTP 3 and all the optimizations that go into frameworks like Next.js, benefiting from those. That'll all be transparent and automatically done for our customers. I think with regards to the reports that the browser makes, I think it's super interesting. And I think that's another point of observability that I was mentioning, that it seems like we're never fully capturing the entire picture, right? So report URI, I know that some folks are looking at that, but when I talk to most websites, they're not really fully leveraging the fact that the browser will report connection errors and things like that, and building that into your entire image of observability automatically would be really cool.
Yeah, I think report URIs are kind of one of those things that are often overlooked, that we can definitely leverage to know more about where we're kind of falling down on the security front. But I think that we can probably all agree that the lack of adoption for CSP is always like a lack of good documentation and like good tooling, really, that helps people just kind of like bake that in and also get telemetry back. So there's kind of like two sides of that story. There's a shift left story, and then there's an actual like operations story to like measure that over time and know how you're doing. Like, are you getting better?
That's something where,
are you getting worse?
That's something where Next.js could help quite tremendously, right? Because like one of the things we do at build time is give metadata to the edge about, okay, what does this build, what does the build result in? And throughout there, we could do static analysis or look at annotations on the pages that say, hey, this page is going to need a certain resource. And then the CSP header could be compiled automatically for you. Because like really what happens with most websites is they have one global middleware that governs CSP, and then they end up with this like gigantic list. Maybe it doesn't stay up to date. It's a pain in terms of DX. It's a pain to test. I've seen websites have errors because it forgot to include something in the CSP list when they ship to prod. So I agree with you 100%. The use or misuse of the technology in that case has to do with insufficient tooling. I think it's something where frameworks like Next could help a lot.
Yeah, any time that we can sort of pave the road from a security perspective, that's a story that's near and dear to me. So, any final thoughts? We don't have a lot of questions coming in. Ooh, there is one question there's one final question I want to make sure I don't ignore, which is like about the performance story. I think that you did a great job talking about replacing the CSS shadow with an image. Is there a story there around accessibility concerns, I think, as it relates to performance and telemetry, as we kind of continue to move towards what is a more accessible web for different types of devices?
Yeah, I actually think that sticking to accessibility as a priority tends to help performance because one of the things I didn't mention in that big iceberg is people creating really complex UI components that try to mimic the native web browser component. And that's not bad to do, but you have to be cognizant that there's a budgeting concern that not every UI, like just creating a massive UI library doesn't come for free. And that if you're not being good about doing the things that Next.js does, for example, with code splitting and chunking, you might be rolling out, for example, I've seen this pattern a lot where websites will roll out a single page application with a bundle that contains the entirety of the component system instead of the components that are just going to be needed for a certain user journey or interaction. As a result, a couple of things happen. You reinvented a UI component that the browser already invented, and the browser already loaded that code, and it's written in C++, and it follows all the operating system standards for accessibility, focus, keyboard navigation, and all that. My recommendation is usually that if you're going to not use that, you have to match, feature per feature what the native one is doing, especially with regards to accessibility. That will increase your code bundle. That will mean a lot more surface of maintenance, and it'll mean a lot more bugs and a lot of other things. So it's not that I would say don't do it. I would say remember that a lot of what the browser has already built is hard to compete with because it's hard to compete with code that has already been loaded and it's already in memory and it's already been extensively tuned by browser vendors. On the flip side, browser vendors on mobile suck. So like everyone reinvents, for example, the hamburger menu component, right? And everyone reinvents it in a way that I would wager that most of them are not accessible, where the hamburger, for example, doesn't have a label or it doesn't have the right area role that says, this is a menu, please open me, and things like that. So what I'm hoping here will happen in the future is component libraries that are akin to what iOS give you will emerge. They will care for accessibility and they will care for performance and code size, and then we'll kind of have best of both worlds. But if you want an accessible website and a performant website, my recommendation would just be for the vast majority of teams around the world, try to stick with component systems that piggyback on the platform itself. And when you can't do that, you have to measure your investment really carefully.
Before I ask a less front-endy question here, I would say I just want to ask, since you talked about components, and I love components with regard to just user journeys and like new applications. Do you have like a reference or some advice for anyone who would say it's too hard to build components at the beginning of a brand new project? Like maybe that's time wasted versus the dividends that it kind of pays to build components right at the outset?
Yeah, so I'm really optimistic that we will be able to have our cake and eat it too, where, if you're working in a new project of Datadog, you can have a very high performance, accessible Datadog component system that didn't take years and years and years of investment to create. So if I were to start it today, I would do something like Tailwind to get the sort of right CSS building blocks, right? Like CSS is almost too low level. It's like assembly. And Tailwind is giving you functional CSS, so to speak, that composes really well and things like that. Then you could go to something like Tailwind UI components, where like they've already built a lot of these components, and then you can customize them. But if you want to go more custom, there's now primitives like React area that'll give you like headless UI. This is a very interesting new trend, like the idea of a headless UI component. So you'll bring in basically composable higher order components or hooks that give you a lot of the right bootstrapping. Okay, I'm going to build a button. People tend to underestimate what goes into building a button. So you'll be able to get a pseudo button. And on top of that, you make it your own. And then it'll force you into making it accessible. It'll force you into just to like give you an interesting reference. So if you retain the hover pseudo selector of CSS on mobile, the mobile engine will try to show the user the hover state, even though there's no hover on mobile so far, because there's no way to like hover your finger on top of the screen and react to that. But the browser will delay you by hundreds of milliseconds. Now, once you know this, you go throughout the entire web and you're thinking, wow, oh my God, because everyone leaves their hover styles in production on mobile. So this is what I'm hoping, I'm not going to have to be chasing teams throughout the world, telling them like, hey, remove your hover on mobile. Like, this is what this new headless UI primitives will give us out of the box. And then we'll just fill in the details. But right now it's really painful. I would say this is why I recently tweeted on mobile web is where we stand to gain a lot, because there's just so much low hanging fruit. And we all use mobile web, and because we don't create on mobile web, I think we haven't developed the right empathy for the medium, but we all use it every day, and we're all kind of like every day, like not benefiting from the true potential of what the web could do there.
All right, I promised that was the last front-end question. It was an amazing answer, by the way, to the accessibility question. It's a topic that's definitely always top of mind for me anytime I try to use a site on different devices. I always turn on the accessibility features to just kind of poke at it and see how it goes. It's reInvent week. It's just about the top of the hour here, by the way, just to level set on the schedule. So just coming to the top of the hour. Our next talk is 15 minutes after the hour. Probably do about 10 minutes more of this open Q&A, give folks a 5-minute break, and then we'll go right into our next talk right on time. But it is reInvent week, so I'm curious to hear from both Zain and from yourself. What are the announcements from this year's reInvent with regard to serverless, since this is a serverless event, that you are most excited about? And we will start once more with Zain, since I think that we've been sort of front end heavy here. So Zain, you're on mute.
Yep, sorry about that.
No
Yeah,
worries.
no, front end is fine. I love front end too, so happy to get insights there. But reInvent, haven't thought too much about what I am expecting. However, I would love to get some updates on Lambda and its compute increase. We often hit Lambda limits, not invocation limits, but actual memory limits, CPU access that is limited right now on Lambda. I know they increased it to 6 virtual CPUs, I think, a few days ago. I would love to see that increase a little more, because that'll help us run some really intensive loads in the serverless world, where we do struggle a little bit. We cater to Hollywood, we cater to these very high resolution video formats that we ingest. And if you're talking 8K HDR, running that efficiently in a Lambda is challenging. It's not very simple. So I'm really looking forward to maybe some more enhancements on beefier Lambdas.
Yeah, I think that line is just getting blurrier and blurrier, right? As we get more of these facilities to schedule jobs on technologies like AWS Fargate. I think the original idea of this was like the EC2 batch service, where you could just like spin stuff up and throw it away. But
Right.
Now there's these 10 gigabyte memory images and 6 core Lambda functions, and then there's Fargate containers.
Yeah, exactly. So one of the themes here is, before we design a service, obviously is to consider would this run better in Kubernetes, where we can control our access to resources, or hopefully it runs okay in Lambda. So yeah, there's always that.
Do you ever find yourself looking at observability data as a means of kind of like homing those jobs in the right place with regard to like, I'm sure there's a sweet spot here, right? That's like the right compute for the right cost for the right amount of execution time, and observability, tracing, performance metrics,
Right.
they all kind of help us decide that. So I'm curious if there's a process that you go through.
We do, and we're definitely improving upon it. But we definitely have Datadog metrics for usage in our Lambda as well, where so we have, when a video an asset enters our pipeline, it goes through about 7 different steps, which I kind of shed light on a little bit in the talk. Some more intensive than others. So yeah, we do have observability over there to see what process is taking longer, how much it's consuming. But video is not super easy to also quantify quality-wise. I mean, there's VMAF released by Netflix, which is an awesome tool to just compare quality automated in an automated fashion. So yeah, to answer your question, yes, we have observability metrics in there for resource usage. And then a lot of the actual output from that test is visual, because we are going to run it on an HDR TV. We'll run non-HDR content on SDR TVs, iPads. So it's a mix right now, but we're hoping to solve it some way where we can run an automated pipeline and just get overnight results on what worked better than the other.
Very cool. So Guillermo, what are your favorite serverless announcements from this year's reInvent?
So we operate, tens of thousands of AWS accounts on behalf of our customers, and our responsibility is to give them a very magical experience where they at the same time can peel the layers under the hood and get the right observability. They get predictability. And one of the issues that we've encountered over time is AWS will roll Node.js runtime updates that when you're operating on behalf of so many customers, you actually find edge cases in the magic of AWS upgrading the software layer of the Lambdas. So one of the things we're looking into is using their new Docker support to have better control over the runtime and communicate to customers better what's going on. So it's almost like their built-in Node.js support was almost too magical to operate at a certain scale. So I think it's going to help. Obviously, I'm excited about the billing model improvements. We see a lot of customers that are doing very simple things. In a lot of cases, they're rendering, but they're hitting a global database. They're hitting a global content distribution network, and they use less than 100 milliseconds. So that's welcome. I'm excited about the better resource primitives that they're giving us. One point of concern, though, is that you go into the more affordances of a full container and a full machine, the more observability requirements you need. So the best example here is if you have 6 CPU cores, now you start needing a lot of the CPU utilization metrics that a full computer has, right? So like the lines get really blurry, but as you said, and yet you don't have that full look at everything like you would in a machine. And instead it gets kind of, it could be incomplete in some cases, right? Like the best example here is that when you're doing a lot of workloads against databases and things like that, and you're opening lots of connections, you start needing a lot more observability at the operating system level. What is this going to do to my gateway that is accepting all these database connections? What connections are being starved and things like that? So I'm excited about Lambda giving us more resources, but it's still not 100% clear in my mind what their vision is for when do I use Fargate and when do I use Lambda 5 years from now. Whereas Google with Google Cloud Run has been a lot more clear. They're saying if you want one-to-one, You configure it. If you want more concurrency per container, you do it. So it's going to be interesting how Lambda evolves in comparison to Google Cloud Run and what the quote unquote right model ends up being. I'm just happy that they gave us this really powerful scheduler with really great boot up performance. At the end of the day, that's how I think of Lambda in my mind. A great code scheduler with great boot up performance profile. I'm excited about what's happening with Firecracker under the hood. So the underlying technology that enables the virtualization that powers Lambda has recently gained snapshotting capabilities. So they'll be able to improve code boots even further. And that's something that always helps, especially with customers that are doing Lambda workloads right in front of customers like we are. So that's still coming, but it's going to be really exciting. And actually, I'm still excited about the announcement from last year, which you talked about earlier, which is provisioning. I think, and this again goes back into like the lines between this container worlds and Lambda worlds becoming blurry, is if you want really predictable perf, you already, as a business, you know your workloads well. Vercel knows the workloads of customers based on traffic. So leveraging provisioning as a feature, I think is a really smart thing to do in conjunction with the blind serverless mode.
Yeah, completely agree. I am a big advocate that there's no one right way to do anything, right? That what we're seeing as a industry is we're really seeing these cloud providers respond to customer asks for more cores, for provision concurrency, for reserved concurrency, and we can build kind of the application that we want on top of that stack, whether we want to use containers or not. I know personally, I'm most excited about the code signing feature, like code signing verification. That's just because I'm a security guy. Anytime I see a security feature that's been a customer ask, that makes me really excited. We're going to deep dive on that on Friday during a Datadog recap on this week in reInvent. But we're just about 5 minutes away from the next talk, and I do want to give folks the opportunity to have a quick break. But thank you both, Guillermo and Zain, for being with us for this unconventional sort of mini panel Q&A for your sessions.
Thank you.
Thanks for your work.
I'll see you guys later.
We'll resume at 10:15.
All right.
With Ridgeline's talk. You'll see Timothy Zaitsev, product technology architect at Ridgeline, to share some learnings on building using GraphQL and serverless. 10:15. We'll be right back. Thanks.
Still like me, oh, but I know they see right through me, cause they listen to my songs, yeah. But I don't care, no baby, I don't care. People always tell me take a breath, hey, hey, hey. I've been looking for something that haunts me all night. I've been staying up hours until the sunrise. Just so casual, always living the same life. I don't really mind, but I just need to take some time to get away. Take for this pain to go away, cause I've tried 100 methods and they always seem to fail. Am I crazy? Don't tell me I'm crazy. I just need to find another way. Hey, hey, hey. I've been looking for something that haunts me all night. I've been staying up hours until the sunrise. Just so casual, always living the same life. I don't really mind, but I just need to take some time to get away. And die, cause I'm so bloody tired, yeah, but I'm alright, trust me baby, I'm alright. I'll just sit back and enjoy the looking for something that holds me all night. I've been staying up hours until the sunrise. It's so casual, always living the same life. I don't really mind, but I just need to take some time to get away.
All right. We're right back at it. I'm excited for our next talk of the day. We're going to have Tim Zaitsev, product technology architect at Ridgeline, here to share some learnings on building using GraphQL and serverless together. I personally know that these two things together can be super, super challenging, so be sure to pay close attention to that. And let us know how you're doing in the chat. Let us know if you like the event, if you're having any problems, if you want to share information about how things are going in your area, what the weather's like, what you're looking forward to next week at reInvent. We want to hear from you in that chat. And we want to hear your questions on Tim's talk so that we can have some high quality questions to ask him at the end of his session here upcoming. So definitely do keep those chats coming in. If you can even just let me know that you can hear me in the chat, that would be super lovely. We don't have the emoji feature in the Zoom webinar, but I do enjoy the emojis.
Hello, everyone. My name is Tim Zaitsev, and I wanted to thank you for taking time out of your day to be here with us. On behalf of Ridgeline's engineering organization, I am honored to be presenting to you as we explore Ridgeline's journey into building natively on the public cloud. A special thank you to Datadog for putting on this wonderful event and being a terrific engineering partner to Ridgeline as we continue to grow. Let's take a look at the agenda and see what we'll be going through today. We'll start with a company overview of Ridgeline. We'll look at the vision and the strategy on APIs, how that supports the vision. We'll do a few quick tech primers. We'll look at this Ridgeline tech stack, and we'll go into serverless lessons learned while building natively. So what is Ridgeline? Ridgeline is a modern platform for growth-oriented investment managers. Founded by Dave Duffield, the founder and CEO of two of the most successful enterprise software companies of the past 30 years, PeopleSoft and Workday. With Ridgeline, Dave continues to create and fuel a culture built upon collaboration and teamwork, motivation and inspiration, and building a company that lasts in the long term. In order to build this company, Ridgeline has set out on an ambitious vision. A modern investment management platform built on a unified data set designed to fuel a firm's growth. So when an investment firm wants to use Ridgeline, it's going to need to do that through APIs. And we've built a modern, configurable, and extensible architecture. So let's look at that API strategy. Best-in-class enterprise API. Our firms need us to be reliable and scalable. We want to be familiar and consistent. And in order to do that, we have to be well documented. Looking a little bit deeper on how we achieve this strategy, we start with a security-first culture. Every API is authenticated and authorized across the stack. We use the most powerful tooling. GraphQL on the back end allows us to answer any number of questions. But we don't stop there. We provide a familiar experience that everyone who uses APIs today is familiar with, so that GraphQL is not a barrier to entry. And we do that with first-class documentation. We make sure that it's easy to use Ridgeline. So let's look at a quick primer on GraphQL. And what is GraphQL? GraphQL is a new API standard that provides a more efficient, powerful, and flexible alternative to REST. So here we can see that there are three forms of GraphQL that we're going to be working with. We're going to first define something, and that's going to describe the data. In this case, we have a project. It has a name, tagline, and contributors. We're going to ask GraphQL, once we've put data into our system, about a project named GraphQL, and we just want to see the tagline. And we're going to get back a predictable result compared to what we asked for. Let's compare that to REST. REST, if I were to ask for a project, I would get back a project ID. Then I would see that there was a tagline ID. I would have to then go ask the tagline service for the tagline ID. And then finally, I would get back the name of that tagline. With GraphQL, you ask GraphQL for the information and it composes the response. It resolves the data in a way that's predictable. And GraphQL Federation takes it one step further. The Apollo Graph Inc. company has created this federation server that takes multiple GraphQL microservices and stitches them together and federates that. So you can ask one question of many services and get answers across all of them. Thank you to Educative, Apollo, GraphQL, and Micronaut for this. If you want to look there for more of this information, the primers there are very helpful. Looking at the tech stack, now that we've done over those primers, we at Ridgeline want to create, to achieve this vision and this strategy, a flexible, configurable, and extensible stack. And we do that by empathizing with the requests that are coming in. So as a firm, I would be sending an API request. And how that would work at Ridgeline is completely serverlessly. We minimize the infrastructure costs. And so we use Amazon's web services and all of the serverless tools like API Gateway, S3, parameter store from SSM, and Lambda especially, and we compose this architecture. So an API request comes in, it enters the public API Gateway. We only have one of these. It enters the router after that. And this is our first Lambda that we've stood up. We will talk about persisted mappings here in a second. And these persisted mappings translate GraphQL, and we pass that to the Apollo Federation server. All of our microservices compose a GraphQL schema and federate to Apollo Federation, so we can ask a question to Ridgeline across the entire stack. Let's look at persisted mappings in more detail. Netflix on the left shows a graph here of multiple devices asking an unlimited number of questions with an infinite number of response shapes to a lot of microservices. And that's the complexity we don't want to pass forward to our users. REST is a much simpler system, but you can see that it requires many more interactions with Ridgeline. So our solution is to predefine the GraphQL shapes that we support. We can restrict the inputs and control the responses, and we map persisted queries. And these persisted mappings set up a contract between the world and Ridgeline on how everyone should interact together. When you use a persisted mapping, you will get back this response every time. So it feels REST-like, but with the power of GraphQL, so we can build quickly. Now that we've got a request and we understand persisted mappings, we can take a look at what that means on a GraphQL level. On top is GraphQL, and that's a lot for someone who has never worked with GraphQL to try and understand. We distill that with a persisted mapping into the following: operations and variables. Send us that, we'll send you a consistent GraphQL response. And again, to the documentation piece, our documentation shows exactly that. If you pass us this operation, we will give you a consistent response. And the beauty of it is that persisted mappings are one-to-one with our documentation. They're directly compiled. They are synonymous. So if it's documented, it can be used, and that is a contract that we have set out. So we have consistent requests and responses, and we have the ability to compile multiple different libraries from these persisted mappings. So our API request comes in, and it's exciting that we get that gateway. We don't have to stand up any infrastructure. Amazon does that for us. So it's very much in our favor, minimizing the infrastructure overhead. We have one public-facing API gateway. When we talked about security first, this is where authentication comes in. Every request to Ridgeline is authenticated. Most of the APIs use API tokens. The requests that require more authentication, heavier credentialing, go through Cognito. And all of these are the serverless pieces. Cognito does a very good job there. Next, we go to the routing Lambda. And this will be the first Lambda that Ridgeline stands up as part of a request lifecycle. So this routing Lambda, we've talked about authentication. Now we're talking about authorization. And authorization is an EFS-based authorization. What that means is, in a serverless world, we don't want to attach disks because that's the chances of failure are more significant. What we've done is use a very new technology for EFS Lambda, which allows you to attach temporary storage to Lambda. And what we are able to do is very quickly, without interrupting the API request flow, check on quite a large number of points to see if an API request is authorized. If it is, we go to route that request to the appropriate place. And we do that with the SSM parameter store. It is a path-based routing, and we'll talk about the differences of SSM and why we chose that parameter store feature. So we know where to go, and we've got the question we want to ask. The API mapping has come in. We've translated that to GraphQL. We've passed that to the Federation Lambda. This will be the second Lambda that we stand up for every API request. The Federation Lambda is a heavily customized Apollo Graph Inc. gateway. We've customized it to be performant and more importantly, performant in our flow. And what it does is it pulls down the GraphQL schema that's hosted from S3 that's composed of all of the different microservices that federate together into this Federation server. And it can now answer requests. So we have two Lambdas running, and our API request is continuing to flow. And now Apollo can send that, and our Apollo Federation server can send that request to the microservice mesh to the appropriate place that it's looked up. And it does that by sending it to a private API gateway. So every one of our microservices has a private API gateway that allows routing to it. This is because we need to speak over HTTP, and our Lambdas need to be able to respond in that way. We don't want to stand up any kind of server, so we use private API gateways. Each microservice is responsible for two more things: exposing its GraphQL schema that does not conflict with anyone else in the graph, and exposing where to send requests. And again, we do that through the parameter store, through the pathing. And so a request has come down through the API gateway into our router, into the Apollo Federation server, and now into this layer. And the answer to the request is resolved, and we send that back out. Two more very interesting things can happen. If it is a federated request, multiple Lambdas can spin up, more than 3. We can get as many as the mapping has allowed. And then when we add pagination, and especially nested pagination, you can have one Lambda spin up. So we'll have 3 stand up as a result of a request. It can respond. We're now back to 2. And now 100 more can spin up because there's pagination, and we need those requests to go through. And they're all federated requests. And so we can have 103 Lambdas, and it can continue down this way. And so the weight of a federated paginated request can get very heavy. In order to know what's going on and why something has failed, we need traceability. And so we've gone all the way through. We've gone through the request. We've done the persisted mapping. We're now into the layer, and we need to look at traceability. And traceability we do with Datadog. We have made a very customized solution for us. So we're able to deploy to all of our regions, and we can send the logs and cover all of the different regions that we need to be able to trace a request across all of our services. Multi-region serverless Datadog forwarder allows us to do selective filtering and log-based metrics. For example, here you can see a log where we're exiting a specific handler, and that ran for 80 milliseconds with a 200 response. And we have different trace IDs that we've set up to be able to do that. Now that we have traceability, we can look at the performance of our stack. And what we're able to do is, to the microservice layer, achieve 90 milliseconds. And that's pretty fantastic for the amount of steps that you heard and the number of hops that happened. More importantly, we have 150 more developers building concurrently, over 50 different federating microservices. This stack is powerful and it's capable, it's flexible. And the best part of it is it's maximally flexible with a minimal overhead. We continue to iterate, and I'm really excited about all of the work that we've done this year to get here. So now that we've done that, and now that we've talked about the stack and we've gone through the primer, let's look at the native cloud and the lessons that we've learned building serverlessly on the native cloud. And so you can see here, this will be lessons that we've learned along the way. And these are the different Amazon technologies that we're using. And I'll cover these, and this may be a refresher to some of you. Some of you may already know a lot of this, but this may be new to some. And so if it can save any pains later, we hope this helps. So security first culture means that we are trying to create a trusted operational environment. And wouldn't it be amazing if we could guarantee that there could never be data that gets exfiltrated or sent out of a Lambda? So we would put that Lambda in a private subnet. Even as early as a year and a half ago, this wasn't very possible because it was so slow and cold starts took so long with Lambda. That was fixed in 2019. And just recently, very excitingly, Lambda VPC endpoints became available. Well, now if I want to invoke a Lambda directly, I don't have to go to the public internet. I can use an interface endpoint, and I can do that. Excuse me. So now it is almost possible to have all of your Lambdas in a private subnet. There are some other services that don't have interface support yet. We hope those get added soon. But the point here is it is almost possible to have a trusted operational environment. Caveat, VPC interface endpoints can add up. They can be expensive if you have a lot of them, a lot of VPCs across all of your accounts, because they run 24/7. Let's look at API gateways. API gateways allow for requests to flow serverlessly through your system, and the goal is to have fast and traceable requests across our systems. Because we need HTTP, our microservices have a private API gateway in front of them, and were we to get to 600 within a specific account within a specific region, we would have a hard limit from Amazon. Well, the idea here is that you could use multiple regions. There are many architecture approaches here, but just a limit to be aware of. Another limit is API gateway invokes Lambda directly. And sometimes you'll get a 500 HTTP response code of failed, could not execute. You'll have different 500s in there, but your Lambda will never be invoked. And that's difficult because you don't have any traceability. So being able to provide the logging of what happened and how it happened, being able to send all of that through to Datadog to be able to see that or to be able to trace that through CloudWatch is very important. 2 notes here, API gateway enhanced metrics can be very expensive. So consider turning those off in development. And the other point here is that you can log full request and response data across stages in API gateways, but should you do that in production with customer data? So be aware of those points. Next, let's take a look at Lambda. And the goal here is, of course, performant APIs, fast responses, and tuning correctly to get the best out of your Lambda stack. And do that all serverlessly. We don't want to run servers. So how do we do that? Well, we really, at Ridgeline, take advantage of the Lambda micro VM cache. That is the layer that stays up as long as your Lambda is warm. and your cold start comes up, you load a bunch of data into your micro VM cache, and you are good to go. You will be fast from then on. But sometimes you'll want to clear that cache out, and there are many ways to do that. The way we found to do it is we programmatically update the Lambda description. That clears the micro VM cache without having to cause any kind of drift. The other points here, monitor your Lambdas and memory timeouts. It's important to do that because you'll be tuning, you'll be spending too much money you'll have performance issues. And the cold starts do hurt your API response times. So consider making sure that you're monitoring those effectively, especially with memory. We've talked about parameter store as our performant serverless store. There are many options on what you can do. That you can run 24/7 systems. You can pay on demand. You can do a lot of different pieces. Redis or Secrets Manager are two alternatives here. DynamoDB is an alternative here, but we chose to go with SSM because of the simplicity of it. It is a cheap system that is incredibly fast if you enable the increased parameter store throughput to give you that 1,000 transactions per second limit. Cache those responses in Lambda micro VM and do consider the trade-offs depending on your architecture and your system. The top point here, structure your SSM hierarchy thoughtfully. The point here is you should be able to pull down just the correct amount based on the path that you're looking for. SSM hierarchy works like a tree, so you should be able to grab just the correct section of that tree and not more or less to make sure that your calls are performant. S3, the simple storage service. Again, the goal is performant APIs. We don't want to be pulling large files and sending those around. And there are limits to how much a Lambda can send and how much it can receive. Same thing with API Gateway. It's very useful for backing large files for Lambda. If we need to pull down the GraphQL schema, for example, we can use S3. And it's there, it's private, it's easy to write to, it's distributed, and it's resilient. Another interesting point here is CloudFront S3 and Edge Lambda support allow you to do very clever authentication and pre-flight checks and a lot of this to make sure that you are serving the correct thing. But with anything, make sure that you are setting your connection timeouts aggressively, especially as there are network transient errors that occur. Your cold starts may suffer if your connection times were too long. It's better just to fail early and try again. You might get a better connection the second time. CloudWatch and metrics. Fast and traceable requests is, of course, the goal. There's really no bad way to trace unless you're tracing everything all the time, and that can just get expensive. So searching all log streams in a log group is really a lifesaver. That picture is at the bottom. Click that button. You'll get all of it, narrow it to a time range, and you are good to go. Unless you want it to go to multiple different log groups at the same time in multiple regions, then you're going to have to start collapsing and combining and being really thoughtful of how you structure your log groups. Well, Datadog solves that for us. We at Ridgeline can search across log groups and regions, and Datadog makes that very easy. And the second thing is log-based metrics. We don't want to impact the performance of our API, and we don't want to do anything that could cause the customer to slow down in their API requests. So we use log-based metrics. That logs the metric out, and it's processed a little bit later down by the Datadog forwarder on the Datadog side. Very fantastic little piece of technology. Limits and service quotas. It's the final slide and kind of the lessons learned. Default limits can be incredibly restrictive, and every time you spin up a new account, they're account specific and sometimes region specific. So a service overload anywhere in your account can cause a disruption to developers and customers. And that's something that we try to avoid at all costs. So we create tools, and these tools scan and make sure that everything is looking well. But be careful, because those tools themselves can cause throttling and connection limits on pretty standard APIs that look like they're going to be okay. The really nice thing here is that service quotas from AWS can help increase limits quickly and make sure that your accounts are all looking good. So we've covered lessons learned, and we've looked at how to build natively across the stack and how Ridgeline does it. We know that logging and metrics allow us to evaluate performance. Our performance allows us to continuously build with a lot of developers, microservice architecture. We use Apollo Federation to put all of those different microservices together, and we route to them using different Amazon technologies to make sure we're going to the right place. We minimize our IT overhead by using serverless technologies like API Gateway. And we get the best of both worlds from REST and GraphQL with persisted mappings that we've built at Ridgeline. We use those to create first-class documentation that our users use to be able to send API requests. And that'll conclude building natively on the public cloud. Thank you so much for taking time with us today. My name is Tim Zaitsev, and have a good day.
Hey, Tim, that was a great session.
Thanks, Andrew.
That was really a roller coaster ride of content, I think, for anybody who hasn't developed against GraphQL before. And I know personally, like firsthand experience, it can be super, super challenging just to wrestle with that whole stack. I don't care what language you're building in, like Python, like Node, whatever. Like it's an experience all by itself.
There are a lot of moving pieces. Serverless adds complexity there, but at the same time, it lets you think about it in this kind of smaller, compartmentalized way.
Yeah, I think what a lot of people really miss when they think about GraphQL is that you don't even have to make GraphQL for an existing business, right? Like you can bolt this on to your existing REST infrastructure, and you can have GraphQL resolvers just sort of like fan out to all these other intermediate APIs or databases. And so it gets crazy really fast. But it's also incredibly flexible. And I think you did a great job talking through kind of your different models for constructing graphs. So thanks for giving us some insight there. We had a couple questions come in from the audience, one of which I don't even know if you can answer here, which is regarding AWS IoT. But I don't think Ridgeline is an IoT vendor, so we might defer that to a sales or other question and answer session.
No, we're not in the IoT space yet. We never know how the financial industry is going to change, but as we continue to use these pieces, it's exciting to learn how it scales, because as the number of requests go up, having that traceability is very helpful.
Yeah, and I think GraphQL has some interesting implications for IoT, just kind of at a high level, because it is very, very efficient in terms of being able to only request the data that you want. So GraphQL is like a boon to bandwidth overall, like query time overall, and also to security, because we're never exchanging data across the wire we didn't intend to exchange. But we did have a good question on the topic of GraphQL, which is, does Ridgeline use Amplify or AppSync to develop any product core services? And I'll ask the question again because my cell phone went off during that. It's one of those spam phone calls. Does Ridgeline use Amplify or AppSync to develop any products or core services? And where do you develop and deploy everything?
Yeah, two questions then. Amplify and AppSync are two interesting pieces of technology by Amazon. Amplify we do use on the front end. And the reason we do that is it does the communication to Cognito on our behalf. And it does that exchange, and we never have to, kind of security first, we never have to store or interact with an individual user's credentialing. We trust and we do that shared responsibility with Amazon to make sure that that exchange occurs. And then we're dealing with bearer tokens and API keys. So that's Amplify.
So let's pause for just 1 second there, because there's a lot to chew on with your use of Amplify, right? Because I feel like as a business, if you lean into serverless, you're leaning into this whole like model where you don't want to necessarily have to manage as many parts of your infrastructure as possible, or at least every time I've chosen serverless, it's been that. And so if you're using Cognito as the authorizer for that, are you also using the custom authorizer patterns in Lambda? And has that been kind of an accelerator for you?
We are, and we use them internally to guarantee that every request is authorized once we come inside to the VPC. And so there isn't any single private API gateway that is unresolved. The part that's really helpful there is we're using API gateways and API keys to do most of that work. The custom authorizers there help us to make sure and kind of do a secondary piece that nothing is unrestricted and nothing is unsecure.
So is there a performance impact that you've seen in that custom authorizer pattern, as far as like taking that token in, having a function that validates it, and then passing that on to the GraphQL resolver?
Our kind of P90 on that's the performance evaluation, kind of in the 90th percentile, is about 3 milliseconds within that custom authorizer. There are times where we will see that go way up. And that's kind of that 10% where we're always struggling. We're always trying to get those down because those impact performance. And those go up to as much as, I think we've seen at 90 milliseconds.
Wow. You know, I was struggling to think of use cases before today where I thought about sub 100 millisecond billing being a big win, but authorizers are likely that place where we're going to see a lot of savings to the customer in terms of that new billing interval.
Concurrency, the whole sub 100 milliseconds, making every kind of request as fast as possible. It's kind of the name of the game here in serverless.
Yep. So how about AppSync? The second part of that question, do you use AppSync to develop products and core services?
Short answer, no. We evaluated AppSync, and when you're starting off with a graph that is completely blank, it's interesting to be able to test out how you're going to shape your graph. The way that we use our application framework that we build internally called Pinecone, the way that we compose our graph and federate it and stitch it together, that didn't mesh well with AppSync. It's something that we constantly evaluate and look back on as the features expand. But Amplify and AppSync, when you're working on a front-end application, work really well together.
Very cool. So the third part of that question, I think, which was kind of subtle, is how do you do your local development against this? Where do you develop? Is it purely an integration environment? Is it a local environment? Do you take advantage of some sort of framework for that?
All of our development, again, because it's microservice based, and we guarantee that every microservice can federate together, our developers are primarily working on their individual part of the graph. They can make keys external, and they can make sure that the federation works, and that's all testing that's done locally. We use SAM local to be able to stand things up locally and make sure that those tests work. But at every step of the deployment process, we push that code up, and GitHub will take it. We'll run a series of tests, and it continues to test all the way through before it reaches our pre-production environments. And by that point, we've run quite a number of tests to make sure everything flows normally.
All right. I know that can be like one of the kind of the biggest challenges, kind of like coming from the potentially like a TDD world into the serverless world. So always great to know what folks are doing with regard to any sort of test environment or deployment workflow, really.
Yeah, the TDD world is still very much a real place to be in. You need to guarantee the quality of your code. And we work really closely, and our QA are amazing people that work really hard to guarantee the quality of the product. But as a developer, I want to guarantee that my code works and that it's not going to affect anyone downstream. And we do a huge amount of pre-commit and then pre-merge checks to make sure that my microservice and my part of the graph doesn't impact or hurt anyone else.
Yep. And I know serverless is kind of it's a big win, right? So when you're first structuring a business, all of a sudden you don't have to deal with all this operations overhead of like building EC2 images or building containers or standing up a Kubernetes cluster, but it doesn't necessarily excuse the need for architecture, right? One of the common Anti-patterns, I know I've seen personally, is just frameworks that create an S3 bucket, for example, for every code deployment that rolls out the door. Do you have anything that was really key to your getting started in serverless as a business, or your specific architecture process that you would be comfortable to share here?
Yeah, I think our DevOps team and kind of this DevOps culture that we have that work so closely with everyone, it's just, I can't thank the team enough. The ability to customize and deploy and really forget about what happens when you send code in a microservice environment and have that combine and create a product, 5 or 6 different major products that Ridgeline offers, all cohesively connect and build a front end for. And with the amount of developers we have pushing every day just to have the DevOps and CI/CD pipelines just connect everything together, it is a huge win to the serverless space.
Yeah, it can be quite a lot of work to like vet these frameworks and tools and really kind of see what they're doing. So I think what I heard as a consistent theme there, and a pillar that's really near and dear to Datadog, is just communication, kind of like breaking down those silos in a very intentional way. And I think that's a theme that we're going to continue to see work over and over as businesses kind of adopt these new technologies. I will ask you the same question that I asked the last set of panelists panelists. We're not even to the panel yet. It's early in the day. Speakers, the question I asked the last set of speakers, which is there a specific serverless announcement from the first 2 weeks of now what is to be 4 weeks of reInvent that you are excited about?
I think we touched on 2 of them. I think this past weekend we cranked one of the Lambdas up to 10 gigs, and we saw kind of instant performance boost there, and it was very nice to be able to test that out and see the win there. We've subsequently kind of scaled it down, but it was interesting to be able to test out what certain kinds of DynamoDB stream-backed systems can do with 10 gigs and a huge amount of cores. And I think you mentioned it, Andrew, the security piece, being a security first culture, is so awesome to see the signing of individual Lambdas. I couldn't imagine what would happen should that fail, but having that extra security piece and making sure that every one of our Lambdas is signed is definitely something we've immediately jumped on.
Yeah, I know that a lot of people have DIY'd things like Lambda canaries and whatnot in the past, and the documentation wasn't quite as mature as it could have always been with regard to hashing and things. So it's really nice to see that as a first-class citizen in the platform. I'm eager to get kind of hands-on with it and poke at it a little bit, especially with regard to containers. But we'll kind of explore that a little bit more in the panel upcoming at the end. So if you're not planning on staying the whole day to attend the panel, definitely attend the panel, because I think we're going to have some really good discussions there. Upcoming in just about 8 minutes, we've got Stackery coming on to give us some learnings about serverless myth busting. Otherwise, keep your questions coming in the chat here. We love to know that you're here with us, because this is in fact a live event with live talks from live people. They are not just aired pre-recorded, so we want to hear from you. If you have anything, seen lots of positive comments come into the channel, actually, just things like, thanks, Tim, that was awesome. So I know on behalf of Datadog, we're very happy to have you here. Thanks for your time to put that talk together. Some good learnings for sure.
Really just a huge effort to the Ridgeline team and everyone that's been working so hard to get these products over the line. And as we go live at the end of the year, it's really just a huge collaboration. So incredibly proud.
Yeah, with that, I think we'll close it out. We'll take a 5-minute break, and then we'll come back with the team from Stackery, since there's no more questions in the open Q&A. So thanks so much, Tim. Great to have you.
Thank you, everyone. Cheers.
Can't you feel the chaos waking, running out of time? But this world is ours to save, so hold the high, oh, it's do or die, oh, now it's our only chance, and if we're going down, we're going down fighting, like it's the end of the
All right, and we're back at it with the final talk of the day. Bits of Serverless, Datadog's inaugural serverless event. Our last set of speakers, I am extra excited for. We have with us today the Serverless Mythbusters, Farrah Campbell and Danielle Heberling, Ecosystems Director and Software Engineer at Stackery, respectively. They're about to bust some common myths for us with regard to serverless. And once again, just a friendly reminder, keep those Zoom chats coming in. It's how we know that you're enjoying the conference, that you're on the Zoom, that you have questions that need answered from our serverless experts. We'd love to hear from you, even if you just like the music that we played during the breaks. You know, we love to see those chats coming in as we go through the day. Otherwise, I'm going to turn it over to Farrah and Danielle.
Hi, we are excited to be joining you all virtually today to talk about serverless mythbusters. My name is Farrah Campbell, and I am the Alliances and Ecosystem Director at Stackery.
And my name is Danielle Heberling, and I'm a software engineer at Stackery.
Before we get started, just want to start off with a quick disclaimer that the content in this presentation contains many anecdotes about our experiences with serverless, and these experiences ultimately shaped our opinions, and your experience and our opinions could be different. Okay, so why serverless? Well, Danielle and I both spent a lot of time talking with their customers about why they are choosing to go with serverless. Serverless allows the app to scale up quickly to match event demand, and then it also scales down quickly afterwards. This saves both on money and performance. It lowers the operational liabilities, leaves that all up to AWS. And, we are seeing a lot of teams that are shipping things much faster than what was planned for. Also with fewer people than allocated for as well. But serverless is also a new paradigm for many organizations. And with that comes some common preconceptions. Some of them are true, some of them are not true. So today, Danielle and I thought we'd go through a few of these points that people make about serverless. We're going to talk about a couple of things that we hear in our experiences, and then we'll conclude if we think these are relevant or true. So to get started, the first one is going to be drum roll, cold starts. So Danielle's going to talk to us a little bit more about that.
All right, cold starts. In order to talk about cold starts, let's start by talking about what happens when you invoke a cloud function. So I, as a software engineer, send an API call to invoke my function that I worked really hard on. Next, the cloud vendor needs to go through all my settings and set up the function execution environment. After that, they need to load up all my code and my modules into that execution environment that they just created. And finally, my code can be run. So when we talk about cold starts, we're talking about steps 2 and 3 here: the setup of the function execution environment and loading up my code and modules. And there's also a term to contrast with cold start, warm start. Cloud functions are ephemeral by nature. So when a cloud function receives a request, it spins up and it sits there for a while. And once it's no longer receiving requests, it spins down. If I send subsequent requests, once it's already spun up, because the function execution environment and my code is already loaded, it can jump straight from the API call to running the code. And that's what we call a warm start. So why might a cold start be a problem? One example that I've come across is if you have an API endpoint and an application that is really reliant on that response from that API call, and it really is important that it comes back in a timely and quick manner. And one other example that I could think of was a slow website. So for example, you go to a website, that website has an underlying API where it makes API calls to get data to load things on the web page. If that API is slow in the response, what the person going to the website is going to see is potentially things like loading spinners. They might just see a blank page. And if that takes too long, they're going to get bored and go to a different website. So that could be a problem for me as a software engineer who worked very hard for that website. I want people to use it. I want people to benefit from going to it. So factor fiction are cold starts a serious problem, specifically in serverless architectures? My take on this is that it's both fact and fiction. I say fact because cold starts do exist. I would be completely lying to you if I said that they were not there. However, I say fiction because from my personal experience, the amount of time for a cold start is typically going to be fractions of a millisecond. So it's going to be so tiny that it really doesn't even matter. And to go along the lines of that, I've also noticed some really awesome improvements from cloud providers in order to make cold starts that time much smaller. So whenever I started with serverless, probably about 4 years ago, the cold start time was way larger than it is now. So one example, AWS released improved VPC Lambda networking. I believe this was about a year ago. And before this, you would notice a big difference between a Lambda and a Lambda that's attached to a VPC. The one attached to a VPC would be much slower to start up. But now I really don't even notice a difference. Also at AWS land, last year in 2019, during reInvent, they announced a new setting that you could set on your Lambda function called provision concurrency. And just to clarify, this is not to be confused with reserved concurrency. Reserved concurrency is a completely different setting. Provision concurrency, however, is a setting on your Lambda function where you can enter in a number, and that number is how many execution environments that you want to have already spun up and waiting for a request. And my one kind of caveat to using something like provision concurrency is because those execution environments are up and running, you are getting charged money for it. So really make sure that you plan and provision according to what you think your request load might be. And then also on the developer side, I, as a developer, can control how many dependencies I have in my code. This can help result in smaller package sizes, less to load. I can also provision more memory in my function. That can also help to shave off some time in cold starts. So next up, let's talk about vendor lock-in.
Okay, so lock-ins, we hear a lot that, people are concerned with being locked in, and why? Well, Lambda is a service platform that lets us run our code without provisioning or, managing any servers. Once deployed, that code can automatically be triggered by other AWS services like Amazon S3, SNS, SQS, so on. To make those integrations as seamless as possible, there are a number of assumptions and conventions that we need to use. Since they are peculiar to AWS Lambda, you might hear that some people might be concerned that they will be locked in, to AWS for the rest of their lives. Other worries about lock-in, is if a manager is hiring a team, it's going to be very, very hard to, get that deep cloud-specific knowledge on your entire team. We hear that, people are concerned what if the cloud decides to charge me more for the managed services that I'm choosing to use. And also that it's more difficult to switch to another cloud. What's the definition of being locked in? So I Googled it, and the first one that came up is that, to be locked in, it means to put somebody in a room, you lock them the door, and so they cannot leave. So fact or fiction? Well, being locked in implies that there is no escape, but that is not the case with technology choices. It's not the case with serverless. It's not the case with databases. It's not the case with frameworks. And it's not the case with a programming language. So my take is that it's fiction. I really like a blog post that my friend Yang Kui talked about lock-ins last year. And he goes on to say that instead, technology choices create coupling. And no matter the choices you make, your solution will always be coupled to something. And moving away from those technologies will require some effort, but there is always a way out. He goes on to talk about, in the worst case, you're going to have to rewrite some parts of your system, and then talks about how Sam Newman defines a microservice as a standalone service that can be rebuilt in no more than 2 weeks. So that will kind of give you a rough idea of the cost if you're using modern architectures. Some form of lock-in is everywhere in software and engineering, and in many ways, lock-in depends on how quickly you can move key elements of your IT presence from the hosting service in question to another location outside that service. And it's whether you can maintain some or all of those key elements in conjunction with it. So, if you can migrate, go local, I would say that you're not locked in. And just, to keep in mind that it's all about weighing the pros and cons and choosing the solution that works best for your use case and your team. And there's always going to be trade-offs here. All right, next step, the big debate is, does serverless replace containers? Danielle's going to kick off that one for us.
Right, so let's start with a very high-level comparison between containers and serverless. And disclaimer that this is by no means exhaustive. I'm sure there's probably more things I could add here, but these are just the highlights that I've noticed just from working in both containers and serverless. So let's start with container services. They are always on, always running, always waiting to accept requests. The only time that they're off is if you shut them off, whether that be through automation or by physically typing in a command. Serverless functions, in contrast, are ephemeral in nature. So they're only going to be up and running if they're receiving requests. Otherwise, they're going to spin down and not be running. And a real big pro to containers is that they're multi-platform. You can take a container from Cloud A and run it on Cloud B, almost exactly the same. And in my opinion, that's a real strength of containers. To contrast, though, specifically a serverless function, that is a managed service provided by a cloud provider, and it is designed to be run only on that cloud provider. So that's cloud provider specific, not as portable. When it comes to patching and updates, if I have a container running, I'm responsible for keeping track of if there are patches or updates out there and applying them. However, to contrast that with serverless, that's part of the managed services part. The cloud provider handles keeping track of that for you, and they run all patches and updates for you. So you don't have to think about it, and you can spend time doing other things. And then finally, these last 2 points, I'm gonna go through a quick example. So let's say, for example, I have an ETL job. This ETL job involves a lot of data and a lot of processing. So it runs for about 30 minutes in a single job. If I send this ETL job for 30 minutes to a container, that's going to be able to handle it no problem, as long as your settings are right and such. However, if I send that to something like an AWS Lambda function, we're going to have some problems. specifically because of the 30-minute runtime, because cloud providers have limits on their services. And in this case, AWS Lambda has a limit called a timeout. So that means how long your function can run before it stops. And as of today, 2020, the limit there is 15 minutes. So if I send it like a 30-minute job, it's going to run for 15 minutes and then just stop because it hit the limit and it's not going to complete. And then I'm going to be sad. So, fact or fiction, does serverless replace containers? My take on this is that it's fiction. And I like to have the opinion of why not both? Instead of thinking in terms of containers or serverless, I like to think of it in terms as containers and serverless. I'm going to get a little soapboxy here, but we as software engineers can be really passionate and really excited about the programming languages and tooling of our choice. Some of us, it can turn into our identity to a degree. But sometimes you really need to take a step back, just kind of a friendly reminder to think about the problem that you're trying to solve. And then think about what tools might be best suited for this. Speak with your team, see what's best for everyone, and use the right tool for the right job. There will always be trade-offs, but at the same time, some tools are better for certain things than others. So make sure you leave your biases at the door and try to think about things from a more holistic standpoint. And I mentioned containers and serverless. There's some really cool hybrid things going on out there now. So from the managed services at the cloud provider level standpoint, we have a service such as Cloud Run. This is on Google Cloud Platform. It's a way to run serverless containers. AWS has Fargate. And also in AWS land, just this year at the 2020 reInvent, they announced container image support for Lambda. And personally for me, this is really exciting because if you're a team that's really invested in container tooling for your development workflows, you can now use container images to package and deploy your Lambdas. And you can still use that old container tooling that you are comfortable and used to. And finally, one of the big issues that I personally had as a software engineer when I started with serverless was being able to run my code locally on my computer, just to get a faster iteration loop of, is this thing working? And in more recent times, AWS SAM stands for Serverless Application Model. There's an AWS SAM CLI that has a local invoke command. So what this means is you can run your AWS Lambda function locally on your computer, just to get that faster feedback of, is this thing I just wrote good or bad? Is it working or not? And I just thought it would be fun to share that under the hood, this tool uses containers in order to accomplish that. So next we're going to talk about is serverless only for greenfield applications.
Awesome. Thanks, Danielle. And I agree that containers and serverless can work together. But I would say serverless plus containers and flip-flop the names. So is serverless only good for, or is it only for greenfield applications? And yes, startups are finding success, and startups definitely want to build with the most modern architectures. They want to save time, they want to save money, and they also want to build better architectures than the competitors, to outpace them. But are legacy applications finding any success? So thank you, Forrest, for this awesome image. Thank you for letting me borrow it. Well, let's talk about a couple case studies from our customer base and see if we can find any success. So MasterStream, this company has reached a point where their on-prem server architecture was limiting the rapid growth of their solutions, and scaling was becoming more and more problematic. And then it came to a point where they just weren't able to scale anymore. So they decided to begin this journey of migrating this 15-year-old PHP app to the cloud using AWS services. And they did this, like piece by piece, just, bringing out the core business logic. This drove a 90% reduction in their costs associated with managing traditional infrastructure. It also increased their engineering velocity by 60x, and this helps them to continue, to outpace their customers. Another one of our customers, there are Mutual of Enumclaw. And the Mutual and Enumclaw engineers were tasked with expanding their solution to more states. This company is 100+ years old. Some of their systems are more up to date than others, but their primary policy ran on an AS400 and a Z mainframe. They both leveraged some forms of COBOL, and they both were fundamental to how this company was doing business. So they decided to work on transforming their policy system. And they went from large queues of batch processing to real-time processing. And then they went from running on an AS400Z mainframe to running on a modern application using AWS Lambda and ECS. And they are continuing to, to innovate. So is this fact or fiction? I'd have to say fiction. We're just seeing too much success out there. In the next couple of weeks at reInvent, there's more stories of legacy success. So if you're thinking about, migrating any of your old infrastructure or updating your architecture, I highly recommend any of these stories. The Registers of Scotland is going to talk about 400 years of Landys and how they've migrated that to the cloud. I'm really excited to hear about how they're doing that. Emphasis is re-architecting their legacy application to a cloud-native architecture in AWS. Same thing with Cedrus. So a lot of really great stories out there, a lot of wins to celebrate, and I definitely plan to watch all of those. Oh.
Yeah, I always like to hear about the diversity of people that use serverless. So thanks for sharing those stories.
Yeah.
So today we covered some high level, more of kind of like a frequently asked question that we get asked about a lot. So we covered cold starts, vendor lock-in, containers, and serverless. And then we talked about some serverless success stories, both with startups and older legacy applications. And Farrah and I, we always love to share the serverless love. So if you have any questions or need any help with anything serverless, or if you just want to have a conversation about, what you're working on and share your knowledge with us, definitely feel free to. We're both available on Twitter. There's our Twitter handles. And thank you for listening to us today. Yeah, I think I like.
All right, last presentation of the day, but certainly one of my favorites. And I know that we've got Danielle and Farrah already promoted to panelists in the stream. So if you can go ahead and just unmute now and say hello, that would be great.
Hey, Andrew, thanks for having us. It was fun to watch that talk and, basically critique myself the whole time. But yeah, thanks for having us this morning.
Hello.
Yes, super appreciate you being here. So I think one of the things that was the coolest for me is this story about how serverless isn't just for brand new greenfield companies, right? It's really for everybody. And whether you're bringing a COBOL runtime even to that, there is a way that you can leverage serverless to accelerate your business. And I think that is one of my takeaways for sure.
Yeah, it's actually been pretty exciting to, watch these customers that feel like they're blocked, and feeling pretty down about, what they're able to do And then, they get to, move into the cloud, and, there's definitely some rough spots there. But as they understand and get better, and as they're, being able to see some of this go live and, to production, and, to be able to, to get it in prod before, before you thought you were going to be able to, that makes teams feel good. Everybody feels like they won the day there. So it's been pretty exciting and, fun to be a part of.
Would you say that there's a little bit of a perception that you have to go all in on serverless versus just kind of start breaking apart a stack at a time? Like what's the advice that you would give to a company, brand new company, or not even brand new to serverless, brand new to cloud, maybe brand new to serverless, coming in, and let's say that they had some legacy code, maybe it's like .NET, classic ASP. What would you tell them?
I personally would probably recommend more of a piecemeal approach, because especially if it's like your moneymaker application, you don't want to have that risk of, putting everything on, flipping a switch, and then having it not work.
But it's possible. I think that's the kind of the big takeaway from the presentation, is that you can cherry pick services out.
You can, and we've seen customers that have done a lift and shift over to EC2, and then once they get over to EC2 and more into the cloud, cloud-based services, then they start to repiece that architecture and rebuild it in a more serverless way. And again, it takes some time, and, they'll run parallel things, against each other. But again, I think it's just, making sure that they, they're focusing on, what is right, good for their business, really piecing out that core business logic and then upgrading from there.
So there's not a lot of questions coming in here via the channel. So I'm just going to try and ask you some from my own sort of wonderings from your talk, which is on your serverless myths. So is there any noticeable difference really in the way that you pre-package things in the cold start time? So people continue to talk about this, like the lead time from a HTTP request or from a job invocation to the function, kind of like getting down to business. Is there anything that I can do as a developer to kind of like reduce that time?
Are you talking about with like in terms of the container image packaging versus the zip?
Yeah, the Lambda runtime package. So the either the Lambda layer, the container now, as we're going to continue to talk about it. So there's like Lambda. I feel like it's more confused now that there's Lambda containers, and there's also Lambda layers, and then there's also zip file upload. So which is the best for cold starts?
I've heard some very great success stories with folks using Lambda layers, because, if you have a really big application with a lot of dependencies that you want to reuse, I've found that to be a really nice pattern. We use them a little bit in our internal stuff at Stackery, but also, regarding like the container image packaging versus the more traditional zip packing for your Lambda function. I haven't had a lot of time to play around much with the container image packaging, but I was watching a reInvent live stream Twitch with a lot of the AWS serverless developer advocates, and someone had asked that question, and the official answer from AWS was, no, they're not designed to have a difference. So that's really exciting, I think.
Very cool. So you did talk a little bit about this idea of multi-cloud and the idea of vendor lock-in, which I know is, I think this is one of those kind of perceptions that people have about software development, that any time that you're building on a stack, you're maybe taking your architecture and sort of ensuring that it runs in a specific cloud. What's your opinion about that? And can you just talk a little bit more about the idea that embracing a particular compute as serverless is vendor lock-in?
I mean, I guess I would say, like, if you're really working on a serverless approach, so you're going to be working on your core business logic, how much time are you taking away from, working on that if you're hiring and looking for, top tier development for, Google, for Microsoft, for AWS? I mean, finding those people, training those people, I mean, like, even making sure, like, retention, like, that would just be such a time suck for not only like the managers, but also the entire team. And so I just feel like that, you're really, it's kind of like missing the point of, really focusing on what's core to your business and your use case, and, working from there.
Yeah, I think this is going to continue to be a theme in the industry, and I think that this idea that we can bring containers to the runtime, like, kind of makes this a non-issue, maybe, or at least less of an issue. And we're
have like the ECS anywhere now, I think that, and like EKS anywhere that was, released, last week. So I think there's, a lot of improvements that are being made to allow you to run additional workloads without having to have a, multi-cloud approach.
Yeah, as these lines get blurrier, it's just going to become less of a conversation. So what do you think are some of the most common challenges from your customer base when they start out, like, brand new in serverless? And I mean, you can talk to this too from existing company and brand new greenfield company if you like, because I think these are going to be different for everybody, or maybe they're the same. I don't know.
There's been a lot of things. I feel like a real common theme, and I probably shouldn't speak for Chase, the founder of Stackery, but I get the vibe from him that the root problem that he was trying to solve was, how do you do serverless for teams? Because there's a lot of, you have Terraform and things like that, which are really amazing and awesome tools. But, like, when you're working on a team, how do you know what's deployed where? How do you handle something like secrets or parameters? And we've been asked questions like that a lot. How to kind of deal with, like, I want this person to have access to this secret, but not that secret. And I feel like another very common one has been, and I mentioned this in the talk too, was local development. Because I came from containers, just run a server on your computer, mostly web development. So it's like, just go to a website, it's there, it works. Whereas with, like, Lambda functions and SQSQs and such, you can't really replicate that on your laptop. So we get asked about that a fair amount. Yeah. Did you have anything else that comes to mind, Farrah?
Say that, setting up the, your CI/CD pipelines and how to integrate with, tooling that you're already using. Governance and security is definitely always a fun one. And those are also fun too, because, as you're going through these, security checklists, everything is so based on on-prem servers and not cloud-based. And, I've been on call after call after call when you finally get on the phone, like the chief security officer, and, he's like, like, we're done with this. This is obvious. Like, we're looking at dinosaur documents here. Basically, he's like, this is all approved because it's just not relevant to, how things are run in the cloud. So that's always fun. And I think, but it also, I think, confuses people as well.
So maybe each of you would be willing to share with us a little today about anything that you sort of had ideas about as developers kind of going into this? Because I feel like all of us, we're a little incredulous kind of going into the serverless kind of track. I mean, I was like all in. I just dove in, the deep end of this. And I experienced a lot of other folks coming back and saying like, why this? Why do you choose to build on this? But what preconceptions did you have personally when you decided to sort of back this as an industry? And were those perceptions kind of accurate as you went forward?
I had a kind of weird perception. I was a brand new software engineer and didn't quite realize that sometimes tools are named the same things as the technology. So when someone said serverless, I went to serverless.com. And at that point, I just assumed like, oh, serverless is just using this framework. I have to use this framework, which it's great. I'm not meaning to downplay it. That's actually what got me into serverless. But I feel like that's probably my biggest misconception, was thinking, serverless is just using this framework called serverless.
For me, I mean, I didn't start out, as a developer. I have worked in operations. At Stackery was my very first, I guess, like customer facing role, really working with the community. But I've always worked at startups. And so I'm like, I'm usually the only one that's not a developer. And through, like our go to market or anything that we were launching, I always felt so helpless. So they, taught me how to update our wiki. So I go through and update documentation. And I always loved doing that. So when I got to Stackery and learned about serverless, and then I, learned that Stackery actually helped you to actually do all the compute for you. It actually did. So I can just drag and drop the different AWS services onto this visual canvas. And then all of the cloud formation is generated for me. So I didn't have any preconceptions. I was just excited about the ability to be able to do things myself now. And it's kind of funny because I've actually gone through workshops at the same time, as people that have developed for a very long time. And I'm not questioning where is, when am I going to get my report? How am I going to know if this was done? So I'm not asking all these questions. I'm just moving through and just kind of learning. And so I usually end up being like one of the first ones finished, and, I like through the wild rides, I got that deployed faster than anybody else. And it's just because like, I don't have all these preconceptions and, not asking and, wondering, where something was before that's not there now.
Very cool. I think it's always great just to kind of dive in to these new technologies and just sort of see what they can do for the business. And I think that is one of the things that like Werner Vogels continues to tout about serverless, is that you can just really care about business and the business process and less about what it is that you're building on. So I think that there will continue to always be opportunities in the serverless space for folks who really want to take the time to just understand the business first and build on the technology almost second, which sounds sad as a technologist, right? That we're putting the technology second, but it's a problem solving thing, right? We're using this to solve problems.
But at the same time, doesn't it kind of feel good that that like the stuff that you're working on actually matters to the end customer? That would be my question.
Completely identify with the customer impact, and also the story that when I build on serverless, less often somebody has to wake up in the middle of the night. After having done ops for a long time, I think ops people are really attracted to serverless because it is reliable, it is scalable, it has fewer problems, and that time that we spend waking up all night long, that's impactful.
My sister is married to somebody that manages ops for a bank, and every single one of, I'd say for the last 5 years, well, except this year, Turkey has been I mean, it's usually burnt because he has a call and, misses getting it out or can't cut it or whatever, but something's always, he spends hours, trying to help somebody on Thanksgiving and also Christmas.
Yeah. It is still new technology though. Like serverless feels like it's been around forever now for all of us, right? But the Lambda platform only launched, I guess it's almost 10 years.
And it was just 10 years ago last month.
Yeah, so it's been around a hot minute compared to most of the other tech in the biz. So we're still building trust. Kind of the way that we do that is to continue to tell great stories with observability, tracing, etc. We'll take one final question before we sort of transition into panel mode, which is from one of our other presenters today. Mr. Zain Raza asks, regarding local development, have you seen any tooling, i.e. local stack, and such that helps with being able to develop locally when dealing with Lambda functions?
I feel like I really haven't seen a lot, actually. Yeah, there is things like local stack. I've also noticed, I'm mostly a node developer, so I've noticed like various packages on the NPM registry where like you can mock various AWS services. Personally, for me, I really like to use the AWS SAM CLI. And that's more of like a hybrid. We call it cloud local. So like you have your CloudFormation stack, you deploy it, and then you can locally invoke your function. And if that function talks to another AWS service, like, for example, an SNS topic, SQS, it's talking to the SNS topic that you deployed up in the cloud. Hopefully in a development environment. I don't think you'd want to do that in prod, but that's my preferred way of doing it. I always love to hear if anyone knows of any other tools though, so definitely let me know.
Yeah, I always used to say that I want to be able to develop it on an airplane with terrible Wi-Fi, right? Like that's kind of the dream for all this. And I feel like that's also the greatest challenge as we talk about these environments that include things like step functions potentially and external services that have underpinnings, and it gets so complicated. And I see this as one of the biggest needs in the space is excellent local testing and excellent facilities for quick and easy mocks for these external services, so that you can have that flight across the Atlantic and get a lot of work done. Any final thoughts, Farrah or Danielle, before we transition to full panel mode? I've switched us to gallery view, so we're almost in full panel mode.
I want to say sorry, you go ahead, Danielle.
Oh, yeah, these Zoom calls are always a little, when do I talk? Yeah, I'm just really excited to be here and glad to meet some more people in the community.
Yeah, I was just going to say thank you for inviting us. It's fun to join everybody here today, and I wouldn't be doing Stackery justice if I didn't say go check out Stackery. If you are new to development, Stackery does make things much easier, and we help in many ways. So check us out.
Right, and yeah, please feel free to reach out to any of our speakers today. Including Farrah and Danielle. Their Twitter handles and contact information was shared in the slide deck, which will be available post-event if you want to get in touch with them. I know as a speaker who speaks at a lot of these online events, it's always great to close that feedback loop, and even just to hear that somebody really loved your talk. So if you can let us know if you like the material, if you have feedback, if you let any of the speakers know that this was an excellent use of their time, please do that. And with that, we're going to transition into our serverless panel for today. So the idea here for the serverless panel is to do kind of a future perspective using Datadog's State of Serverless report. So for those of you that don't know, data. And if you are a panelist, then you can unvideo mute so that we can see your face join the gallery. That'd be lovely. We produce this report periodically called the Datadog State of Serverless, which shows trends from our perspective of how people are using serverless, what they're doing with it, and maybe in the future it'll include things like security components or things beyond just kind of like function execution runtimes, popular languages, etc. So we want to kind of use that as a driver to go forward, because we have this baseline for industry information, but we want to think about where's the industry going to go as we see more adoption here, because we might see new companies adopting serverless or additional companies or existing companies adopting serverless as a means of kind of accelerating their business. Like a great example, I think, is fintech, right? Where they're pulling in all this COBOL code now with custom runtimes coming on as a means of kind of getting rid of some of their legacy infrastructure. But where's it really going? So I'd like to kick things off with a definition here. And I want to welcome Darcy Rayner from Datadog, who you've also not seen today. Wave to the folks, Darcy. Darcy is one of our serverless experts at Datadog. And while he was not a speaker, he will be joining us for the panel. Everyone else you've heard from or seen today. So let's start with a definition. And I think this gets really, really fuzzy. Like this gets increasingly fuzzy. So what is each of your one sentence definition of what serverless means to you? And I will do a round table for these, by the way, just to prevent handoffs. So let's just start with my top left personality, who is Farrah. What does serverless mean to you?
Sorry about that. I had to unmute. But I would say, serverless, you get to spend your time focused on things that make you different and that are better ways to, outpace your competitors and deliver a better experience to your customers. It's a way to focus on the business logic instead of, reconstituting the underlying infrastructure.
All right, let's go with Guillermo next.
I kind of mentioned this in my talk, but I like the concept of toil from the Google SRE book as the idea of what you want to eliminate from your idea of managed infrastructure or your day-to-day of operation of your production service. Any manual repetitive work that is undifferentiated and doesn't contribute really to the product and grows linearly with the size of your traffic, your user base, number of customers you have. So serverless to me is the set of technologies that allow you to delete toil from the conception of the technology that you're working with.
All right, how about Danielle?
Since you just said one sentence, I'll keep mine to one sentence. Using someone else's servers, and these servers auto scale as events come in.
Tim.
I think everything above is perfect. For us, it's minimizing the IT overhead that we have to do on a day-to-day basis. That toil is really important.
And finally, Darcy.
Hey, yeah, I would say it's anything that reduces the amount of operational overhead that you're dealing with, and I think it's it's a lot more than just compute. It's anything that you can scale down to zero and have automatically scaled for you. It's entire architectures. It's microservices. It's a really broad range of trends. I think they're all kind of heading in the same direction of manage less.
My definition, and I mean, feel free for anyone to disagree here, is event-driven and ephemeral. So, and I mean, this is going to be so that's my one sentence, by the way, so I can fit into my own rule set, but moderator's privilege, anything that fits inside a compute workload and then the actual environment gets thrown away. And that historically has been the big differentiator for me personally between an actual serverless compute environment and a container, where a container might have some state on a host for a while, is that the throwaway nature of the runtime. So feel free to share some thoughts there. Don't be shy.
I think stateless is definitely a big part of serverless, but we see that trend kind of changing with EFS Lambda, with more things coming and adding the way to preserve state across these. And even the micro VM cache, you definitely have state there that you can leverage. It really is blurring the lines on a day-to-day basis.
Yeah, the existence of provisioning of Lambdas as a way of tuning the latency characteristics, especially at P99 of your service, is kind of undoing that property that I was also very excited about. The reality is that you do need to think about the allocation of resources, and we touched on it with Zain, with even your service limits, right? You have to be aware of, okay, there is an allotment of resources that are there for me. And on the concept of transient state or ephemeral, while the function instance is being reused, there is a state there, and that state can even cause bugs. So I think it's a trend rather than an absolute lack of state. It's like trend toward more recycle, more frequent recycling. It reminds me a lot of Heroku discovered that their pods, their dynos, if they were stateful for too long, they would accumulate a lot of problems over time. So they would just automatically recycle them. So it's interesting to think about it from that perspective, because dynos weren't getting us so excited about serverless. So I think I agree with you regardless, is that they feel more stateless for sure.
Any thoughts, Darcy, Farrah?
Yeah, I think they definitely, there is like hidden state in Lambda, which is a very like real thing. You do need to think about the number of like, HTTP connections you're pulling, if you have a very high volume service, and there are like scaling characteristics of Lambda, which are kind of different to like, traditional compute workloads. When you have like a lot of, simultaneous concurrent like invocations, and they're like scaling very horizontally, that can create, a lot more like downstream like pressure, by creating a lot of like, redundant connections. So thinking about that and planning it is very like, it isn't something you just get for free. And statelessness isn't, or, statelessness is where you start. And then, sometimes you need to like bend it a little bit.
An example of the statefulness of Lambda being a foot gun that we see a lot with our customers that are just getting started with serverless is they deploy a function, they connect to some service to get some data, and then they are like, okay, it works. And then the life cycle of the function continues, it gets thawed, it comes back alive way later. Then the client naively tries to write to the TCP socket, they get a connection reset, the client SDK of the data store provider they use doesn't retry. That category of connection failure, which it should, but a lot of software either doesn't. And now they find that when they came back to this stateless, magically scaling service, they get a 502. So they went from instant success to let time pass to what the hell is going on, to unwinding everything and researching how the client SDK works in a serverless environment. So the hidden state there, like you called it, Darcy, is quite a bit of a shocker to people, because we all tend to think of the overall system as a stateless, but there's this transient statefulness that can be a foot gun.
Yeah, I think it's interesting too, and I particularly avoided the word state in this question because I think that state is a little loaded here, because there's all these different ways that you can persist state, right? If you have database or you have EFS volumes, I like to think of this as the mutability or immutability of the actual container itself. And there are read-only like Docker containers, right? But in Lambda, or at least in AWS Lambda, you have specific guarantees with regard to like syscalls, mutability of the file system itself, mutability of the code that actually runs there, that aren't always necessarily true in a Docker environment. So when I say ephemeral or transient, that's generally kind of my personal definition as like security hat sort of person.
Yeah, and I do think we're seeing like more and more like hybrid models, which is sort of halfway, in between containers, which still ephemeral, but like even more stateful than Lambda. So like Google Cloud Run, for instance, or like the way like Knative like functions are built. You can be handling multiple invocations simultaneously. Again, that can have side effects. So it is it is like a spectrum, and you do have more and more like to one end fairly stateless, with some like side effects between invocations, and then like all the way to like containers where you're running it with processing more and more events in parallel, like on a single like instance.
So with those definitions in mind, I would be super interesting to just hear from everybody on the panel what you think succinctly is an excellent use case for farming out to serverless, and an example of a business use case that's maybe like not necessarily a good fit or a particular challenge to farm out to serverless. You just jump in here, anybody that has something that springs to mind.
Something that comes to mind is that we moved a couple workloads away from serverless that were originally designed like that, because we were able to like very quickly test out a hypothesis, and then we moved them into a stateful container workload because it was cheaper. So the idea of an invocation, it kind of relates to what Darcy was talking about with more concurrency per container instance or function instance could help there, like what Google Cloud Run is doing. But Lambda as it is, for certain things that see a lot of throughput, could be really expensive. So you move away from it.
Yeah, I would definitely agree. Like, I think, looking at Lambda, for instance, like we're seeing more and more tools to like reach higher like scales and like throughput, but there are like, side effects from, that like very horizontal scale that Lambda like tends to go for. So I think, if you're in startup mode, I think there's a lot of like opportunities to like start with Lambda. And, you find out pretty quickly if you're hitting a use case that like it's not going to be able to support. Usually it's the cost that's telling you like it's, time to move that workload to something else. Lambda's a great starting point for a lot of use cases though.
Kind of in the past, I've seen it very successfully used for image manipulation and image processing, and we've seen even so far as PDFs be successfully done in the Lambda workflow system. For Ridgeline's case, we're obviously doing our entire API structure based on serverless, so it's a new world for us to be able to run an entire request through multiple different products and have an eventing system that can attach and connect and all of that. So the possibilities seem to be endless.
Yeah, I think another thing that would be good for serverless is IoT. So if you think about companies like iRobot, like they've gone pretty much all in on serverless, just, so many devices out there sending little bits of data back and forth, very event driven.
And do you think, Danielle, that that's primarily because of their need to have like disparate bits of data coming in sort of at an unpredictable rate? Or do you think that's because of the cost and scale factor?
I think it might actually be both. Yeah, I can't really fully speak for the folks there, but that would probably be what I would guess, both for cost and not having to think about, okay, how many instances do I have to provision? What might my traffic be during these hours? Just being able to scale out without having to really think about it. And then you can focus.
Yeah, I would agree with that, because for IoT, you might want to make your ingestion point as close to the device as possible. And you're not going to have a normal distribution of devices all across the world. You may have some areas that are busier at certain times. I think IoT is a great fit for serverless for that reason.
So changing gears for a minute here to kind of like lead into a little bit broader discussion. Show of hands, who here is familiar with the shared responsibility model for cloud computing? Okay, pretty much everybody's responsible, or everyone is familiar with the shared responsibility model with regard to cloud computing. I think for serverless, and AWS actually, after many years, produced one of these specifically for AWS Lambda, which I think is great, that sort of shows this separation of compute provider responsibility from customer responsibility. What direction do you think that we're going to see that shared responsibility model go with regard to serverless compute? I had a cat come into the frame. If nobody saw that, this is what events from home look like, is this cat.
Fluffy.
Who knows, no matter what, when I'm on a call and would love to be the center of attention. But let's responsibility model. Do you think it's going to transition more to provider responsibility, which would likely result in increased cost, or customer responsibility?
I'm personally really interested in this in the future-looking perspective of this conversation. Lambda as a whole, as we've kind of started to go down the serverless model, the more compute we can add, especially with Firecracker, the more connectivity we can have. Now it'll be, I'm offloading my extra compute cycles into Firecracker. And that to me is really exciting, but really blurs that shared responsibility model. For now, we already see it where API Gateway will, as I mentioned, sometimes fail to invoke a Lambda, and that's on us to handle. So I'd be glad if it was completely owned by Amazon, but or any kind of owner, but it seems to be very shared.
Yeah, I would agree with that. It's very difficult to, like turn around to your customers sometimes and, things are failing and just point like the finger at AWS. You do need to, think about like contingency plans, if things can go wrong as difficult as it can be. It just turns out like, the vast majority of the time, letting, a cloud platform provider and their like army of like, operations staff, like, handle those situations ends up being like a win rather than like trying to roll more of the infrastructure yourself. But it is difficult to like explain that to a customer when you're using a platform and they're having outages.
And the customer, rightfully so, kind of is like, so what? It's not, you're the one providing the product, fix it. And so we try very hard to have the disaster recovery, the failover, all of the different pieces be able to be instantaneous. But that is one more piece, and quite a complicated piece in the serverless space to be able to fail over to different regions.
I always love the so what of these conversations. There's one of my favorite security speakers is Joe Fitzpatrick, and he has this habit of always giving his point and then doing a so what. Why do you as a speaker care? So I think that we could take this to a so what, which is like, what would be the so what of a provider taking on more of the burden in favor of a customer paying more potentially? And I see that as better defaults, sane defaults, right? Because as an industry, we've really learned that anytime a provider introduces a default that doesn't work for security or doesn't work for everyone, no one changes that until they have an outage or an incident. So I know for me, the so what of that shift in the shared responsibility model is always everything's going to be safer, better, more reliable. But I'd be curious to hear other thoughts on the same vein.
I mean, like one thing I've been interested in is like, we have serverless, but is there like, like the data centerless or like the regionless, abstraction that sits on top of that? Like, like what are the tools that need to be like available before, we have multi-region, and it's easy, like we can deploy to multiple regions, for Lambda and, get compute across multiple regions, but like, how do you do databases across multiple regions? How do you do like all these other services, like in a multi-regional way that provides like decent like failover? I think that's like a really, really hard problem, and it's a hard like abstraction to build, just because of like some of the computer science fundamentals around like state and how like things like cap theorem or like how those would function in a multi-region context. But I think having providers like take on more of this means that they would have to have like be able to like run your infrastructure in a way that's abstracted even from regions, I think.
Yeah, I think you nailed it. There's almost two coexisting trends. One is deploy your functions inside of VPC tied to a very specific database, even a very specific region. And that one, it doesn't matter if Lambda itself is global and you can deploy it to 20 regions or whatever. If your dependency is on a data store that's inside a specific region, so there's no failover opportunity or very limited failover opportunity. However, on the other side, we're seeing the emergence of these global databases, right? So we use Cosmos DB at Vercel, which has lots of very interesting properties for global distribution and global consistency as well. Similarly, Fauna and other databases are coming out and saying, you don't have a specific origin, because we'll replicate your writes globally, we'll act, and then your reads will be really fast. So a combination of this new breed of data stores and the developer and architect being aware of the global consistency model and the distribution model would make it such that your function can literally get, distributed anywhere, or at least close to all these regions in which your database is replicated to. And then that disaster scenario of like US East is completely melting down gets alleviated very smoothly, I think.
Yeah, I think we're going to see, if there is an adoption in serverless as compute, I think we're going to see better and better foundational technology for data stores. And that's like the simplest way that I can put it, right? If we continue to use like kind of the legacy tech database bindings, legacy ORMs, they're either going to adapt and find a way to be multi-region and multi-tenant, or we're going to see something else kind of emerge, and that would be my prediction. And we were kind of already seeing it, like stream processing and things like Kafka and these new foundational technologies that are kind of overtaking the market. But I think we'll see more.
Yeah, so something we hear a lot from our customers is, can you ensure that all the data that pertains to my account is only in Europe? So there is almost this tension between like, you want to operate globally, but you want to comply with certain like data locality rules. But I think, that's also where you mentioned like there will be better primitives on the data layer that make sense for this world, like, database shards that can get relocated, kind of like durable objects, or row-based, geo-replication. And the database is not really in a particular place, but there's a particular affinity point. So my point about even like the transient statefulness of Lambda that even relates to a lot of what you're saying, like using legacy data store bindings and then being surprised by the impedance mismatch with Lambda. So I'm really excited about like what innovations we'll probably have in this space in the next few years.
Yeah, and this is a nice segue into the next question, because I think that themes like cryptography and user agency over data in a shared provider model, like as we see this shift where more and more compute is going to the provider, and as application builders, we actually, either for legislative reasons or for our user base or for ourselves, can't trust the provider as much inherently. What shifts do you all personally see as wins in the security space for serverless? And cryptography could be a part of this. Like, you don't have to say that, though. That's just my...
Blockchain.
Don't say blockchain.
I know, like, you know, at Datadog, you know, my team in particular, we're pretty excited about code signing. You know, we provide like a lot of, you know, libraries to, you know, third parties as like via layers, but also like, you know, like published in other ways. And like, I think being able to like give people a lot of confidence that, you know, the code that's running, you know, in their Lambda that they can't see, you know, they can't really just download it, is, you know, comes from a place that they can trust. I think that's like, you know, really, really important. I'm glad, you know, like I used to, you know, my previous job, I used to like build a lot of, you know, serverless products. And I think like the one thing we were always like fighting against was like, you know, old security requirements around using VPCs around everything. And we were always like, it's going to add 10 seconds to a function. So I'm glad, you know, like AWS fixed it in the last like year or so, and like it's faster. You know, and like bringing like things like, you know, KMS like into Lambda as well, and being able to like sign your secrets very easily is, you know, like super convenient. So yeah, I think like there's a lot of tools like out there right now that are like pretty available for people to use.
To that, obviously signing the individual lambdas, but the network and how that network interacts within a VPC, private subnets and all of that, to Darcy's point, kind of being able to spin up cold start faster, be able to attach ENIs, to be able to make it so that the network traffic is secure and we don't have to worry about it leaving the network unless we explicitly want that data to go where we want it to go.
Jokes aside, I think the blockchain space has some interesting parallels with what we're doing. And as you know, Tim Wagner, the creator of Lambda, went to Coinbase. Now he's starting a new thing that I think he got some interesting ideas from what I read about his startup, you know, founding essay. He did get some interesting ideas from the blockchain world. And one of the things that relates to this idea of like global data replication and security, and at the same time, is that if you have some encryption primitive and you manage mostly data with private keys and public encryption schemes, then I think a lot of the problems with databases go away. Obviously, it's always been this perpetual, you know, unicorn that everyone's been chasing, but I tend to liken a Lambda function to an Ethereum smart contract. And then the Lambda function can apply a transaction over data. And right now that database is just going through a lot of unnecessary plumbing, whether it's the age-old connection pooling problem with Lambda, but also the idea of, well, you have to be in a very specific VPC that has all these cold start problems that I think mostly we should not be worrying about. And then there's a problem of like availability and like whether your function today gets deployed to a very specific region, right? And that idea of like the data moving around or failing over, et cetera, becomes harder to achieve. So hopefully we get something like what Ethereum promises, right? Which is that your smart contract is transactionally applied, is fault tolerant, and you're dealing with like memory registers. You're dealing with the data being there, right there where you need it. Like the function gets brought to the data, so to speak. That has been remarkably difficult to achieve with Lambda. It requires all this kind of infrastructure as code stuff. And luckily for us at Vercel, we tend to work with data providers like Headless CMS or Headless e-commerce that are already doing the workload of making their data globally available. So it becomes less of a problem, but it's still kind of not great. Like a lot of the compute side has been worked out, but the durability, persistence, memory stuff has not. So I'd love to see that fixed.
Yeah, I think to put that succinctly, like whenever we think about the problems that we're experiencing in modern day, like all the sort of classical compute problems, they all come down to the integrity of the environment that's doing the compute. So like, I won't mention any of the hot political topics right now, but there's a lot of environments in modern day that require high integrity compute. And I mean that in the mathematical provable sense. And this is an area where we don't really have excellent solutions as an industry, particularly with regard to serverless. But serverless could be a hero for these environments.
I agree.
These attributes, ephemerality, code signing, etc., to be able to sort of...
It's like it's almost there.
Create a custody chain for a single transaction that occurs in a way that's reputable. But that's like an entire webinar that we could do.
Yeah.
With that, we have 10 minutes to go in this Q&A session. So I'm going to transition to a less heavy topic from the Q&A, which is we have this Datadog state of serverless study. One of the things that really surprised me when I looked at it was the two leading languages were Python and Node, which are, I mean, they're very popular languages, right? But if you're building on serverless, you're looking to mine, every second of performance potentially out of the runtime. Where do you think that's going? Like, do you think that we're going to see those sort of wane in favor of languages that are more concurrent, especially with the advent of more cores, more memory, et cetera? Or do you think that we're going to see it stay the same?
We chose Python as our language primarily because of the ease to get to deploying onto Lambda, because of the ability for the mathematical calculations to plug into it, to be able to do all of that, and seeing Python be still the fastest cold start time. Node is right there with it. It was a nice validation. Personally, I'm incredibly excited for Rust to see that kind of come up and become the next big Lambda language. That's me personally.
Yeah, I suspect the reason adoption for these dynamic languages is so popular with Lambda is there is no compilation step when you're deploying unless using something like TypeScript or a transpiled language. So it means that for simple use cases, it's very, very fast to deploy, and it's very, very minimal tooling to set up and deploy. And on top of that, a lot of Lambda workloads are very IO bound, but they're only processing they're not processing highly concurrent numbers of connections, because it's one invocation. So for most use cases, I don't think jumping to a compiled language with better performance will make a massive difference in your performance. So I think that's why it sees a lot of adoption for those two languages.
Yeah, I know we at Stackery primarily have our Lambdas in Node, and the reason for that is just because the ease of being able to go, seamlessly from the front end to the back end. in mostly the same language. Like there's some nuances in each environment, but at the core, it's still the same language.
Yeah, I agree with Darcy that the reason they're so successful is that they work well. So you might think, oh, if I rewrite this Lambda in Rust, like it's going to be way better in Node, but you might get some P99 benefits. But one thing we do with Next.js that's really cool is so we handle all the bundling of your functions transparently, because we're already using Webpack for the front end. When we generate SSR functions or API functions that we let customers deploy as Lambda functions, we're taking advantage of our compilation pipeline to produce highly optimized bundles. Something we might do down the line is produce the V8 pre-compilation cache, pre-parse compile snapshots that you can give it, so that in addition to all the cold boot improvements that have been made, instead of having V8 have to do extra work when it first initializes, you can snapshot some of that work at compile time, which is a nice, easy win. And that would make Node get even further into the territory of compiled language. That said, what I'm really interested in right now, and I didn't think I would be, is WebAssembly, because I think it was you, Andrew, that called it micro regions. Like the cloud is composed of so many differently sized regions, especially when you get to global content distribution networks, right? And so the WebAssembly that could be run at the true edge in a micro region will have much better performance and multi-tenancy benefits similar to a V8 isolate compared to the full weight. And I mention full weight kind of as a joke because a micro VM is already so lightweight, but there's still a great perf improvement when you do something like WebAssembly at the edge. So we're looking into that right now, and it seems really promising. But then again, as Danielle said, the benefits of just I know JS, I deploy it everywhere, are pretty massive for developers. So it'll come down to a market thing for me, not so much my preference.
Yeah, hiring is certainly a challenge and continues to be a challenge even in 2020 to get folks with serverless and the talent in the language of your choice. In prior projects, I've actually been able to break out functionality from Python to Rust and then bind to Rust using like clib stuff for like little tiny bits of functionality where that was practical. My prediction would be as we see more streaming data, that we're going to see a greater demand for concurrency as streaming data moves to serverless reality. Because you might cherry pick 100 events off a Kinesis stream or Dynamo database stream instead of 10, and be able to parallelize those. But I don't think anybody, like it's everybody's game at this point, and it's going to come down to tooling and your ability to hire with regard to adoption. I think if I could predict kind of a curve, that would be my prediction.
Yeah, and cost will make that happen, right? Like if I tell you, hey, this Lambda invocation costs this much, but if you can rewrite it in WebAssembly with these constraints, it costs this much less, then you can decide for yourself what you want to do.
Yeah. And I love that you brought up WebAssembly, because I think WebAssembly is an answer to so many problems. And it's a little bit under-adopted as far as solving compute problems on the front end, like farming tasks out to the browser. One of the other evangelists in the team just made a photo booth in Rust and WebAssembly. And it's amazing how performant and desktop-like that experience it is. She actually tweeted it out today. It's purrybooth.com. If you want to go there, there's a tweet on the Datadog somewhere for purrybooth.com. But it's this amazing WebAssembly app that re-implements modal dialogues like you would have experienced in Windows for a photo booth. And it is shockingly fast how performant the WebAssembly is. So I do think that WebAssembly has a place here, and it's an offloading compute from serverless functions. So before we close it out, we have 4 minutes left. I really want to know my final question, which is, what's the craziest thing that you've seen somebody do in serverless? Or it could be, if you want to reframe craziest, it could be the most creative thing that you've seen somebody do using serverless. And we could just do a round table to wrap it up.
I can start really quick because I did it. It's go to pokeless.vercel.app. And what I did is I put in a Pokemon emulator inside a Lambda. I actually use this way of explaining that Lambdas do indeed have state. So if you happen to hit the same function instance when you play my emulator, I'll reuse all the state of the Game Boy emulator that I'm keeping in the transient storage of the function. And then I use Redis and a bunch of other things to like propagate changes if there's multiple functions being called at the same time. So it was obviously the biggest hack that's been done on Lambda, but it's a really good way of learning how the actual technology works at a low level and what it's really capable of. So I'll share it in the chat in case you want to see it.
Any other crazy stories?
Oh, I thought you were going to go around. I mean, as a whole, it's Ridgeline, right? It's a company built fully leaning into serverless. We're completely adopting every piece of it that we can get. The more we do, the faster the team goes. Microservices built around fully serverless technologies. As we continue to grow, the more we put out, we're hungry for it. So seeing Datadog do it, seeing AWS do it, and just the more adoption we get from the industry, the more tooling, the more exciting it becomes. So please, everyone, keep working through it and let's all build serverless together.
I'm always really impressed to see the legacy apps because at Stackery, we have a customer, they're in the finance industry. They had all their stuff on mainframe computers and they adopted Stackery to gradually, move it over to Lambda. And it's always just kind of interesting to hear stories about people running like COBOL and Lambda and things like that. And just being able to have success with keeping the money maker, but also just kind of being able to push forward to my bias of, more fun architecture, something that's a little more scalable, manageable.
Yeah, so like recently I started a little bit of a side project kind of inspired by games that my team has been playing over Zoom. So we've been playing like a couple of like turn-based games every week. And I've been like messing around a lot with like WebSockets and using that to build like a matchmaking like lobby system. It's super powerful. I've noticed that you can like for very, very like little, you can like power a lot of like very simple sort of turn-based games, could be written to like run on a serverless computing load, while you have like a stateful connection like via WebSocket, from a browser front end. So I've been very, very impressed by it, and it's very cheap.
Another one on the subject of WebSockets, I just posted is we built this little demo called static.fun. And what it shows is that you can combine functions with the pub/sub system. So this particular demo allows you to create any subdomain .static.fun, and then it allows you to save your page with any kind of HTML content. And what's really cool is that if you share the URL with somebody that you build, like andrew.static.fun, and then you make subsequent changes to it and you press save, it'll publish the changes over WebSocket. So we want to build this to make the point that you can decouple your function request response lifecycle from the publish subscribe WebSocket system, and those two worlds can still work well together. And obviously there's some downsides of doing it this way, like you're writing to a database. In this case, we're using Fauna to write and read. And then as a side effect, we write to the WebSocket. So it's not perfect insofar a more adequate system would subscribe to the Fauna up log or something like that. But it works well for things where a best effort event that accelerates some front end is desired.
Awesome. With that, I think we have to wrap up because we're going to go to Stephen Pinkerton today. But before you all drop off as panelists, thank you so much for sharing your insights, your predictions, your talks all day today. Sincerely, we've been getting a lot of positive feedback in the channel, people asking for the talks. So that's always an awesome sign. If you're attending, please definitely do continue the chat, continue to ask questions. We'll answer them. We'll do our best to answer them. And this content is going to be available afterwards, but do follow up with us or any of the speakers if you have any questions on any of the content at all. And with that, we are going to move to Datadog's very own Stephen Pinkerton for a Datadog demo and some closing thoughts on the future of serverless with Datadog.
Awesome. Thanks, Andrew. Can you hear me?
We can, in fact, hear you.
Awesome. So very excited to have heard all these great insights from our panelists and partners today. Thank you, everyone, for joining. This has been our first serverless event, and we thought it'd be great to just bring together all these experts in the field to answer everyone's questions and just talk about what the future of serverless looks like. And I found this very interesting today, and just very cool that we could bring together some of the serverless community. And this is our first time also doing this over Zoom, so excited to have had the chance to try this as well. So what I'm here to talk about is a new announcement that we're making around Datadog for serverless specifically. So one of the things that our customers ask us a lot about, and I think it was touched on today, is like with serverless, you accept certain trade-offs. So sometimes we're sort of passing the pager to a cloud provider to help make some scaling decisions for us. And so there's certain things we don't need to worry about anymore, but there's a new set of problems because as we talked about today, like serverless is a bit of a leaky abstraction. It's imperfect to get everything right exactly. And at the end of the day, we're still running code on computers in a room somewhere. And in order to handle that abstraction, in order to scale our applications, we sometimes need to think about different problems. And so as we talked about today, this is like, or what Zain talked about is like concurrency is a big issue. So at the end of the day, you still have a certain number of instances of your functions running somewhere. And what we frequently hear is, okay, but like, how do I know what to monitor? How do I know, what's a good threshold for this? Or should I set up a monitor on every individual Lambda function I have, or on every service, or on all of my Lambda functions in aggregate? And so we've spent some time making this much, much easier. And so what I'm excited to be here to announce is, let me share my screen here, is a new way for, is my screen sharing, Andrew? Cool. We're excited to announce these smart insights. So these are automatically generated insights based on the data that you're already sending in with your Lambda functions through metrics, logs, and traces. And so these will make automated suggestions around things that you can be doing to fix your infrastructure. So this is, okay, I can do a better job scaling, or I can save money this way, or I've over-provisioned my Lambda functions, so I've given them too much memory. And so with this, we'll make functions, or we'll make suggestions on the serverless page that you're already used to. So that's one of these screenshots here where we'll show you like, oh, okay, this function's cold starting a lot, or I'm using a lot of memory. And then I can click into that function. And we have a brand new invocations view where we simplify the experience of, what's previously we were looking at traces and logs kind of as separate things, and we've unified them. So everything is automatically correlated into what you're thinking about, which is invocations. And at the end of the day, that's what we hear our customers are thinking about. It's I care about my functions, my applications, my invocations. And so with this, we're tying everything together automatically and showing everything in one place here. So we have our insights automatically highlighted for how many error logs resulted during this invocation, or okay, so I know that in this example, like this function was flagged for running out of memory, and we can go and see exactly the invocations that are running out of memory. And this is really great so that we can hunt down specific traces and invocations for, maybe for a particular user ID or to a particular region when something went wrong, and we can dive in from there and ultimately get to root cause and get back to a healthy state where we're not being paged. So that's our announcement. We're excited to enable this for all customers in the next week, and would love to get your feedback. We have a public Slack channel. If you Google for Datadog Slack or go to chat.datadoghq.com and sign up, we have a serverless channel where all of our engineers, some of whom you've heard from today, sit around, and we have a very active community of developers there building serverless applications. So with that, I'm going to hand it back to Andrew with the demo. Thank you.
Datadog provides visibility into your serverless functions so you can deploy them to production with confidence. This is a real-time out-of-the-box dashboard view into your most critical serverless metrics. You can see the number of invocations for functions in your AWS environment, alongside data like slow executions and timeouts, allowing you to change configurations as needed so customers are not affected by any slow functions. You can see estimated Lambda costs and identify which functions are returning errors and begin your troubleshooting process. This is a high-level view into all of your metrics. To gain visibility into each of your serverless functions, we have the serverless homepage. This is an aggregated view into all your serverless functions, with critical metrics like invocations, errors, and duration up top. You can customize the dashboards to number of timeouts, the specific type of error, and even save the views to share with your team or save time on recreating the context in the future. There are facets on the left to quickly slice and dice to a specific function, AWS account, region, and more. We see a spike of errors and hone in to see which functions were affected. Immediately, we find that the post-coupon prod function has been invoked significantly. The function is called when customers apply a coupon at checkout and has been producing errors in the last hour. Let's dig a bit deeper to see what's happening in the function. We're immediately greeted with metadata about the function, like allocated memory, runtime, and region, alongside tags from the function that Datadog automatically pulls in with our AWS integration. While troubleshooting the error for this function, we need to be wary of any recent changes to the codebase. With Datadog serverless deployment tracking, we have a stream of the deployment events and an understanding of who pushed the changes. If we see one of these events correlate to a spike in errors, we know exactly who to reach out to and what commit to revert. You can also correlate any change in health metrics to recent deployment or configuration changes within your Lambda functions. Let's pivot to look at the traces generated by the post-coupon prod function. As we scroll down, we can hone in on all the invocations or look at just the invocations that produced errors. Let's click in to get more insight into these requests by visualizing it in the Datadog flame graph. This trace is a unified view of a request that started on an e-commerce application, running on a container, and then called a Lambda function to apply a coupon at checkout. We can see the full request time and health metrics of both the container and the serverless function, alongside correlated logs through automatic trace ID injection. As we triage through the error, we can see that the root cause error was a Lambda function updating the ad campaign for this coupon. We can click in and identify that the API rate limit was exceeded. We'll want to investigate the increase in the number of API calls and potentially reach out to the partner to increase our limits. This is a detailed view into a specific serverless function. To visualize transactions across your distributed serverless application, the Datadog service map is the best place to start. This is a high-level view into the architecture and health of all your microservices, including serverless functions. You can tell by the color of the nodes if the monitors set are producing any errors. Let's look for the post-coupon prod function and see if any of the upstream or downstream services in the wider application are affected by the API rate limit error. We can pivot to see the metrics, traces, and logs related to the affected services to troubleshoot immediately or notify the team responsible for this service.
All right. With that, that is the closing demo for our serverless event today. Stephen, are you still on the call? If not, I'll just go ahead and close it out here. It's my hope that you heard some very common themes today on the topic of serverless, that you can apply serverless at any scale of business to do things like future-proof, solve problems, and increase performance. I hope that you saw that there's a rich community of folks waiting to share their knowledge with you. Those are our speakers from earlier today, and they're happy to talk with you at any time. After all, they are part of Datadog's rich community. We have a community Slack as well with a serverless channel that you can join. The industry is telling us that many ways serverless is here to stay, and technologies like Datadog can help you monitor your serverless environment as you mature, adopting a little or a lot of serverless as we go forward. So with that, stay safe, stay sane, and if you're so inclined, please feel free to sign up for a Datadog trial today. Use the link on screen that'll be thrown up after the event. Questions, comments, reach out. I'll be on Twitter and the community channel on Datadog Slack, and Andrew.Krug at datadoghq.com. Thanks. See you later.